So shall we begin?
Yes, please.
Okay. A very good morning to all present here. I welcome you all to the third day of our 1 week ATAL FDP on Foundation of Data Science and its Applications, Advanced. Today, we have 3 sessions. In the first session, we have Mr. Vishesh Deep, who is an engineer from IIT Delhi, a life and corporate coach, TEDx speaker, and regional director of the Art of Living Foundation. Mr. D has conducted several workshops related to trauma relief, drug and smoking addictions in various esteemed institutions of India. He believes in inspiring people from all walks of life. I welcome you, sir. So shall we begin with your session?
Yes, please.
So please, could you share your screen if you have a
No,
presentation?
am I
Otherwise,
visible on the, am I visible?
yes, sir. Yes, sir, you're visible.
That's, yeah. So I would just request
Okay.
all the esteemed faculties who are present out here for the FTP to switch on the cameras because I'll actually share a fun fact with all of you before we start. I'm having a very different internet connection. So I won't know if you're listening to me or I'm hung up. It's a good idea if we can switch it on. Yeah, the next few minutes if we are there, and also I'll be also imparting a few things from my experience, which I'll have to tell you and correct you also on the screen. It's if you are okay with it, I'll be grateful for that. Okay,
Look,
so
hello Vishesh, this is Professor Nidhi. I've been talking to you for this
yes, sir.
FTP.
Yes.
Yeah. There will be few faculties over here, and even the participants, they are not given the rights to switch on their video and the audio. So I request the organizing team members present over here that they can switch on their camera.
The, correct. That will be good.
If
But
you want us, yeah, please.
they'll be active on the chat, right?
Yeah, they'll be active on the chat.
That is also good. But if all the rest of the organizing committees also they can also switch on the cameras, it will be lovely.
Yeah, I'll just see who all are there in the organizing team. I'll just put a group on the WhatsApp group so that people join and switch on the camera.
Sure.
Give me a minute.
Yeah.
I think in the meantime, we can start with the session.
Correct. So before we start with this session, I want to ask you a small question, all of you. It will be a good idea if you can respond on the chat, all of you. What do you think is this session all about? If you can just type it on the chat. And since all of you are faculties, let me tell you, there's no negative marking. You can type wholeheartedly. So what do you think is going to happen in this session? What brings you to this session, particularly this session in the morning, when you're busy with your schedule, waiting for your replies on the chat?
Yeah. Palak, what you can do is you can ask the participants if there is anyone who is willing to, switch on their camera so we can give them the rights.
Okay, sure.
They can raise their hands if they want to switch on their camera and mic.
Sure.
So Mohan Rajji says teaching and learning. Okay, what else? So this session can be a two-way communication. Stress, anxiety, failure, how to deal with emotional issues. Okay. It'd be about something like stress buster from routine life. Okay. Fair enough. What else? Regarding personal skill development. Okay. Dr. Jyotimani says this. All right. What else?
The title in itself, Vishesh, says a lot. Art of Living. We all are existing as of now.
Correct, Nidhi ma'am, correct. So since all of you just round up to that article called as The Art of Living, let me ask you another question now. Let's say tomorrow you have a flight to catch at 6 a.m. in the morning. And somehow at 11 p.m. in the night, you get a call from the airlines that the flight has been preponed to 4 a.m. कल सुबह आपको 6 बजे एक फ्लाइट पकड़ना है, लेकिन बाय चांस आपको एयरलाइंस कॉल करके बोलते हैं कि आपका जो फ्लाइट है वो प्रीपोन हो चुका है 4 बजे तक का. So I want to know in the chat your reaction. What happens to you? What response is there when you hear this out? When the flight has been preponed, what happens to you? I want to know it from you. Because if you answer these questions, then only I can build upon the session. Yeah, just give it a shot. What happens when your flight is preponed? How to adjust time? Rituji says, great. What else?
I will say a little less sleep.
A little less sleep. Fair enough. What else?
Maybe a long time at the airport before I reach the venue. If let's suppose I'm on an official meet and going for a conference, it has a set time.
Correct, correct, correct. Tension, well, little tension on the chat. People say, very good. I need more answers on the chat. Come on, come on. Let's throw it up. See, I'll tell you one interesting thing about life. This is one of my teachers told me when I was studying. So I graduated from IIT long time back. It's been almost 15, 16 years. And, I've been meditating for almost 15 years and teaching people how to meditate for almost 10 years. So he told me very interesting thing, that person. He said that the way you behave in a class, that is exactly how the students will behave with you in your class. So I expect all of you to just write down as much as you can. Yeah. Tension built, pre-planning to be done. So if I say that a lot of you would, you would have made plans. 6 o'clock, the flight is there. 3 a.m. I'll get up, do a little bit of packing. 4 a.m. I'll reach the airport. 6 a.m. I'll catch the flight. But suddenly, when it gets preponed, whatever time you had to sleep, like 11 p.m., the sleep does not come. First, there's a little bit of frustration. What nonsense! These airlines people, they don't want to do anything at all. They just want to change the timing so that people miss their flights and they get more money. Huh? Second, let me get up. Okay, now I have to get up at 2 so that I reach the airport at 2 or whatever I have to do. I don't know what to do. But to sum it up in one line, can I say the thought of catching the flight is more tiring than catching the flight? फ्लाइट पकड़ने का विचार फ्लाइट पकड़ने से ज्यादा थकावट दे रहे हैं, isn't it? What happens is there's too much of planning, there's too much of anxiety, there's too much of anticipation and expectation involved with anything and everything that we do. Yes. And anytime the thought of doing things is more tiring than doing it. It's just not about catching the flight. करने का विचार करने से ज्यादा थकावट देता है. You notice this thing in your life. You are such dynamic faculties and you've been teaching for so long. But I'm sure you've noticed this, that if you are busy throughout the day, you have lectures back to back. In the evening, you're still energetic. But if you have like 2 or 3 lectures and little bit of meetings here and there and just administrative policies coming in, you'll be more tired. Because the thoughts dissipate your energy more than the work that you actually do. Isn't it? So let us come back to this point when you had to catch a flight. See, you have to catch a flight. You have to do that. Something that has to happen lies in which tense? If you can tell me on the chat. जो चीज होने वाली है वो कौन से काल में है? Can you type it out? If you can tell me that. Which has to happen lies in which tense? Hmm? Excellent. Future. Hmm? So any time that you feel anxious or you feel a little fearful is always about the future. We think that the future offers a lot of good things. There's a lot of joy when you think, if I achieve that, that will happen. If I achieve that. But I'm telling you, every time you reach that point, you want more. So it's kind of a pseudo happiness. You became an assistant professor. Let me become a professor. Let me become the head of the department. Let me become the VC. After VC, let me go as, as an OSD to some place. It's a never ending game. All right. But have you also noticed when you're doing this work, you just look at this small word, for example, true or yes. And those small words can bombard you with different thoughts which have already happened. Oh, I remember I had said yes, then I had to regret it because somebody had told me that and I did not like it. And then I was regretful for a lot of things that he or she told me. Something that has already happened lies in which tense? If you can type excellent past. See, our mind is such a dynamic faculty that it keeps on vacillating, oscillating, fluctuating like a freely suspended pendulum. I hope a lot of you are from the engineering college, right? So I can just talk in a physics language itself, right? So it oscillates and fluctuates like a freely suspended pendulum in the past or the future. Where do you need to be? That's one of the most important questions in life. Where do you need to be? If the mind is fluctuating in the past or the future, where do you need to be? That is the question of the session today. Just expecting your answers on the chat. On the present. But we don't really. That's exactly the thing. That's exactly the case. The mind vacillates and oscillates and fluctuates like a freely suspended pendulum in the past or the future, but need to be in the present. Why? Because we are not aware of it. For example, now this is a rapid fire round, and let's play this game on this program called it's the fastest finger first. So if your answers are the most correct and they come close to what my expectations are, I am telling you, I'll just take out your contacts and I'll send you an Amazon hamper if you win it towards the end of the session, for sure. And I'm pretty particular about my words. So let's just be really quick on the keyboard now. How many of you have ever felt angry in your life? Sometimes in your life you felt angry. Then you can write I on the chat really fast. Okay, you feel angry. Okay, if you feel sad sometimes, lazy, lethargic, कुछ नहीं रखा है इस दुनिया में, सब मोह माया types है. Then you can write IS. I sad, no? IS. Okay, good. Excellent. I love the responses. And how many of you felt jealous? Then you can write J on the chat, J for jealous. Okay, very nice, very good. And how many of you ever felt happy without any reason, just like right now? Mast hai, chal jayega apna. Then you can write H on the chat, H for happy. Oh, pretty cool. Very nice. Now, my question to you is, have you noticed your breath pattern when you're angry? Have you noticed it? How is it? If you can just type in one word, it's rapid. Excellent, Preeti. It's fast, right? Wow. It's a little erratic. Yeah. How is the breath pattern when you're sad? It's slow. Sometimes you're choking also. It's very deep and it's very, it's coming very late and it's very deep also. And sometimes we choke also. Yeah. So can I say you are sitting in a normal state of mind right now in a happy-go-lucky mood? If yes, then you can type Y on the chat. If you're sitting in a normal state of mind. So let me tell you a secret now. Till the time I pointed it out, you didn't even know that you were breathing right now. जब तक मैंने नहीं बताया था तब तक आपको ज्ञात भी नहीं था कि आप अभी श्वास ले रहे हैं. कुछ लोग चेक करें. सही बोल रहा है. See, we do not pay attention to it at all. Why are we not in the present moment is because the awareness is not there. The alertness is not there. And the founder of Art of Living, Gurudev Shri Shri Ravi Shankarji, says that if you are aware, 50% of your issues are already solved. A lot of us are not aware. How can you teach a lesson to somebody who's sleeping? Isn't it? You have to wake up to learn that lesson. Yeah, seems good. So going ahead, the awareness, Do you have any idea how much amount of food do we consume throughout the day? Any idea, like in kgs and grams? Just give me a vague idea. Give me a vague idea. Anything. 1600 calories, okay. So can I just mold it a little and can I say it can be 1 to 1.5 kgs throughout the day? Yeah, seems good. And how much amount of water do you intake throughout the day? 3.5 to 5 liters, correct. 5 liters is the ideal, but 3.5 to 5 liters is something that most of us should be doing, right? As it is becoming humid nowadays. Huh? But do you have an idea how much amount of breath do you inhale and exhale throughout the day? No? It's astounding. 11,000 liters. देखिए कल मैंने बहुत खाना खा लिया था, आज नहीं खाया, उपवास रख लिया. Yesterday I had a lot of food, today I fasted. कल मैंने बहुत पानी पी लिया था, आज नहीं पिया. Yesterday I had a lot of water, I did not drink it today. कल मैंने बहुत सांस ले ली थी, आज नहीं ली. Nothing left. Yesterday I took a lot of breath in, today I did not. Nothing left, isn't it? Yeah. See, we are not aware of our breath. Forget about the mind. Our ancestors were so intelligent, so intelligent. What they said, all the answers to your questions are right under your nose. आपके सारे प्रश्नों के उत्तर आपकी नाक के नीचे हैं. How? No breath, no life. No breath, no life. KNOW, life. KNOW, breath. NO, breath. NO, life. How? This is very, very interesting. See, you only told me na, when there's a different emotion, you have a different breath pattern now, isn't it? So every emotion has a particular breath pattern. You reverse the breath pattern, you can reverse the emotion. This is called science of breath. And we do not pay attention to it. The only time that we've been paying attention to it is in the past 3, 4, 5, 6 months because of COVID. The only thing that COVID attacks is that you cannot breathe. Even in etc. is something that we can deal with, isn't it? See, if you dissect our lungs and you spread it end to end, it covers like 11,000 liters of breath which comes in and out. But if you spread it end to end, it can cover an entire tennis court. They're so huge. But we only use 30% of our lung capacity, whereas 90% of the body toxins, including our emotional stress, gets thrown out because of the lungs. And we're not aware of it. Yeah. So today I would be, if you allow me to, I'd be sharing a technique which can instantaneously give you a lot of different aspects in life. If you would want me to. But for that, I'm sorry, I don't know your name, the organizing person. Yeah. If you can just give these people a lot of rights to switch on their cameras, because I'll have to correct them if people would want to. This is a very beautiful technique. If it's possible. So
if the participants are comfortable, they can switch on their videos. Some of them have been given the rights.
all right. Yeah. So I'll just tell you about this beautiful technique. It's called as Nadi Shodhan. But why do we need this technique? Let me tell you. A lot of people told me in the start of the session, stress. Stress is of two types. One is in the mind and one is in the body. The body one comes because of three reasons. First, the mind. Second is your tampered schedule. Third is your lifestyle. So what do I mean by tampered schedule? It is not sleeping in time, not having an apt amount of sleep or whatever. And third one is lifestyle, when nothing is regular in your life. There's no regular routine whatsoever. And the first one is in the mind. Let me talk about that. That is extremely important. So, if you feel that a lot of people blame you, a lot of people are against you, or you are being victimized at a lot of places, your shoulders are in a lot of pain. And the neck area, the cervical area is somewhat compromised. Hmm? If there's this continuous process in your mind that, you know, the finances aren't managed properly, I'm not earning enough, I'm not getting valued enough, then the lower back is in somewhat pain. And if you're suffering from anxiety, this is something very interesting. A continuous, uh, you know, test of anxiety to your body is the heartbeat gets faster, and you suffer from a syndrome called as IBS, the irritable bowel syndrome. So whatever happens in the mind, its reflection is in the body. I just gave a few examples for you to understand that. Whatever happens in the mind, the reflection is exactly in the body. What is Nadi Shodhan? So according to the modern science, we have something called as a nervous system in our body, isn't it? The nervous system, what it does, it communicates to different parts of the body through a system called as the nervous system. And in those nerves, there's this phenomena called as synapse through which you communicate. Yeah. But if you look at the ancient Indian culture, we say there are 72,000 nadis, which is very close to the nervous system of the modern science. But also, these nadis communicate messages from one part of the body to the other part, but they're also energy channels. So whenever there's a pain in the body, somewhere the energy is also stuck up. Hmm? See, so Nadi Shodhan, what it does, it helps you to release it. If you would like to learn it, you can write Y on the chat and we can go forward with it. Otherwise, I can just change the module and go somewhere else. If you would like to learn this technique and benefit yourself from it.
I think,
Yeah,
Vishesh, we can discuss it.
we can
At least
discuss.
I want to discuss.
You want to do it, right, ma'am?
Yeah.
Yeah. Okay. Great, great, great. So it's a very simple technique. You might confuse it with there's a small pranayam that comes in. It's called as Anom Vilom, but it's not that. Let me tell you what it is. So right in between your eyebrows, there's this point. Uh, if we call from the spiritual front, it's called as the Agya Chakra. In the in modern science, we call it as the place of conjunction of the pituitary and the pineal gland. That is where the ladies put in bindi. In South India, it's a very common tradition for the gents also to put in vibhuti also there, right? So two of our fingers touch there. I'll tell you how. It's a very simple process. But if you can just show me your left hand, if you can just show me your left hand on the screen, even if you're visible or not, I'll just presume that you're showing it to me. All right. And then the tip of the index finger touches the tip of the thumb. It's very subtle. It's not pressing hard. Just make an entire zero or a circle out of it. It should be like this. I hope you can see me. All right. Perfect. Just show it to me like this up front, all of you. Yeah. And then you turn it around. Show me the palm of your hand and place it on your knee. All right. Second is show me your hand, right hand. Can you move your hand like this? Can you just do this? Like Mugambo Kushua types, if you can. So if you can, then there's not much stress in the fingers. Huh? It's good. So you fold the tiny finger and the ring finger. Tiny finger and the ring finger, you fold it. And then you form a C with the two fingers and the thumb. You can see this. Perfect. So these two fingers, they come in between your eyebrows. The thumb comes on the right side of the nostril, the ring finger comes on the left side of the nostril, slightly touching it. Simple, right? Let's just repeat it for the people who are, I'm not seeing them. Just repeat it once more. The left hand, touch the tip of the index finger to the tip of the thumb. Okay. and reverse it and place it on your knee. Okay. Right hand, hold the ring finger and the tiny finger, form a C. These two fingers go in between your eyebrows. Right thumb, uh, the wrong fingers you're doing. Yeah. The first two fingers, the index and the ring finger, they go in between. Correct, 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 correct. This goes in between your eyebrows. The thumb comes on the right nostril, the ring finger comes on the left nostril. The tiny finger is just relaxed. Okay. So what I want you to do is, for some minutes, two to 2.5 minutes, we'll just close our eyes and just follow my instructions. My eyes will also be closed. Huh? Let's close our eyes. Breathe in from both the nostrils. Close the right nostril with the help of the thumb. Breathe out from the left nostril. Breathe in from the left nostril. Close the left nostril. Breathe out to the right nostril. Breathe in from the right nostril. Close the right nostril. Breathe out to the left nostril. Breathe in from the left nostril. Close the left nostril. Breathe out to the right nostril. Breathe in from the right nostril. Close the right nostril. Breathe out to the left nostril. Breathe in from the left nostril. Close the left nostril. Breathe out to the right nostril. Breathe in from the right nostril. Close the right nostril. Breathe out to the left nostril. Breathe in from the left nostril. Close the left nostril. Breathe out to the right nostril. Breathe in from the right nostril. Close the right nostril. Breathe out to the left nostril. Breathe in from the left nostril. Close the left nostril. Breathe out to the right nostril. And relax. And slowly and gradually, let's open our eyes. The ones who were able to do it, I hope you're feeling a lot more focused and less thoughts are there, and the mind is a little more calm. If yes, you can type Y on the chat. Great. Super. Just practicing it for 2.5 minutes, 2 or 3 times a day, can suddenly make you come back to your nature. And if you're suffering from acute anxiety issues, I wanted to tell you this also. This is a very beautiful technique. So you need to make your lips in the formation of creating an O. Just create a formation of O with both of your lips and breathe in through that, through the mouth only in that O formation. And breathe out through the O only. Breathe in. Breathe out.
One simple question, Vishesh.
Yeah.
When you are breathing in, your stomach should go in And when you are breathing out, you should relax. It should come out.
Not,
Is this the
not
correct
really.
pattern? Not really.
No, no.
What is to be
So,
done?
so the breath is, see, let's go to fifth grade of science a little. The,
Okay.
the lungs are like balloons, right? So when you inhale, they inflate like balloons, and there's a part just below the lungs which is called as a diaphragm. So it gets pushed down and it straightens up. Diaphragm is like this, but it gets like this then. When when your lungs are filled up, they inflate it. And then the stomach has to come out.
Okay.
So that's also one of, thank you for pointing it out, Dr. Niti. It's also one of the major reasons for stress. So, if your stomach is going in while you're breathing, that means while lifting something heavy or doing some strenuous work, or your schedule has been a little topsy-turvy, the breath is not coming properly. The entire process of having a well or a healthy body is having a healthy spine. And how is the spine healthy? When it gets appropriate amount of oxygen, and the lungs are pretty much responsible for that. See, if the cervical area is a little more stressed out, if the thoracic area just below the cervical area, that is the rib cage area, the spinal cord just behind the rib cage, if it is stressed out, you feel pain out there, that means you're not getting enough oxygen out there. So the lungs are breathing in and breathing out, but they're not working fully. Like I told you, we're only using 30% of our lung capacity. So to correct it, I'll also tell you how to correct it. So tonight, when you're about to sleep, you put the heaviest book on your belly. You're lying down on the bed, on your back, you put the heaviest book on the belly. And when you're breathing in, make an effort to lift it up. Do it 10 times. When you breathe in, make an effort to lift it up. And it comes down automatically. It'll just get back to the normal quotient. So it's
Right.
okay, even if you are breathing, when you're breathing in, the stomach is going in. There's nothing wrong. But in the longer run, it is something which is not not a good idea. There are three types of breath that we actually take. One is the abdominal breath. One is the thoracic breath. The third one you don't need to know at all. These two breaths are the most important ones. So if you think you're doing the thoracic breath, that means all the oxygen is going up. It's not going to the navel part. So digestion would be a little screwed up also. So the stomach movement or the bloating is a common scenario in that aspect. Hmm. So it's a good idea taking it from the navel first. If you see, the breath actually comes from the side of the navel. If you just pay a little attention, it will come from the side of the navel. So the navel, around that area, the stomach starts inflating. And if it is happening opposite to you also, it is happening from the side of the navel only. So we can correct it while you're lying down tonight on the bed, it will happen. But talking about the thing that I was just teaching you right now, the straw breath is called as a straw breath. It's excellent remedy for instantaneous relief from anxiety. Or if you're feeling really hot and the palpitation has increased, it's an excellent way to do that. How much time we do it? Maximum of 2.5 minutes, not more than that. Because it dries up the throat a little. It's okay. It's doing it this much. Yeah? Done? All right. So should we move ahead? If you like this exercise, whatever we did, Nadi Shodhan we did, would you want to take a step ahead so that you are like fresh to start a new day altogether? And the mind is extremely calm? What do you say? All right. So,
Yeah.
but before that, I'll say let's do a little bit of movement. We've been sitting for some time now. Let's do a little bit of movement, and then we'll go into that process. Huh? Just if you can, just show me your hands. Okay, and just shake them, shake them, shake them, shake them. Yeah, shake, 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 shake. It's okay if you have rings and bangles. If they fall off, we'll pick it up. Don't worry. Just shake it, shake it, shake it, shake it. Shake it. A little faster. There's a lot of dust that is there on us since the last 1.5 years. We've been just sitting in front of the screen. Huh? Come on, come on. Shake it, shake it, shake it, shake it, shake it. Also shake your head a little. Just relax your body, relax your hands. Yeah. And relax. Keep your hands the way they are, the way I've kept it. Just exactly the way I've kept it. So they're facing each other. The hands are facing each other. You would feel some small ants on your hands, like small movement. Move the left hand towards the chest, right hand outwards, the way I'm doing it. Right hand towards the chest, left hand outwards. Right. And if you see, if you try and compress the space, it will not get compressed. There's a magnetic kind of a repulsion out there.
Yeah.
Okay. Can you feel it? Excellent. Very good. And if you expand, it will expand against the palms of your hand. Right? It is expanding, right? All right. So rub your hands now. Let's a little vigorously rub it. All right. See if it's there now. It's gone. So you would be wondering, what is this? It's magic. So, there are different times in our life that we feel differently. For example, uh, there are times when you come to your office in the ancient times, at least when you used to come to your college. So you will feel that today you can accomplish any task whatsoever is given to you. And there are days when you didn't even want to come, or you didn't want to even get up from your seat and go for a lecture. Hmm? The difference in these 2 days is your energy level. Hmm? And energy depends on quite a few sources. The first is the food. So what do we talk about food is that if you can just, even if your screens are off, if you can do this, this is the amount of food that you should be having at one point of time. Close it. Some people would be wondering if this is not even starters, but okay. At one point of time, this is the amount of food that you should be having. This gives you energy. If this amount of food is you take, this gives you energy, right? Otherwise, the rest of it makes you lethargic. Second source of energy is sleep. It is said if you are above 30 and you are less than 50, ideal time to sleep, ideal amount of sleep is 7 to 9 hours. 7 to 9 hours you must be sleeping. If you're not sleeping that much, the stress is going to come in the body and it will reflect on your face, reflect in your body, it will reflect in your functioning day to day. The energy levels will be low. See, when you slept enough, then you feel really energetic throughout the day, isn't it? The third is the breath. See, every time you lift up a heavy object, you make a very, very different face. And when you drop it down, it's, huh? So every incoming breath energizes the body, every outgoing breath relaxes the body. हर अंदर जाती हुई श्वास आपको शक्ति प्रदान करती है, ऊर्जा प्रदान करती है. हर बाहर जाती हुई श्वास आपको और विश्राम देती है. And the fourth part is very interesting that we learn today, but it happens through the breath. A lot of you would be saying, "Arey, when I've tried keeping my eyes closed, but I can't." There are a lot of thoughts that come to me, right? So let's play the small game. I want you to close your eyes for a bit only, for maximum of 30 seconds, and just listen to my instruction. Whatever happens, do not think about a monkey. A monkey which is wearing a tuxedo, drinking tea, making a lesson plan, eating food, throwing spits at you. Do not think about that monkey. And let's open our eyes. I'm sure the monkey came and bothered you a little. But let's do it one more time. This time, whatever happens, do not let the monkey come in. Okay? Let's close our eyes. Now the monkey has changed his dress. He's wearing a kurta pajama. He's wearing a hat, a Himachali hat. He's also having a little bit of pan and spitting left and right. And now he's having a banana and making faces at you. Breathe in and breathe out. One more breath in and let go. And slowly and gradually, let's open our eyes. I'm sure the monkey would have come, but would have let go of it. And something helped you to let go of it. And that was the breath that you were taking. See, if I tell you not to have the monkey in your mind, it is coming in it. And you expect when you close your eyes, no thought should come. And if you keep saying this thought should not come, that is the thought which says, hi, good morning. Isn't it? The thought of not having a thought is also a thought. कोई विचार ना आए यही विचार है आपको तो ये भी तो एक विचार है isn't it? A lot of people think that meditation is focusing. Absolutely incorrect. What is meditation? A mind without agitation is meditation. I repeat, what is meditation? A mind without agitation is meditation. So a lot of us feel that I have to focus, no thought should come. If you have to focus in meditation, then what would be the result of meditation? See, you are more stressed of doing meditation because you have to focus in it. No thought should come. This I should meditate. Huh? Meditation, the process of meditation is deconcentration. I repeat, the process of meditation is deconcentration. The result of meditation is concentration. So when we did this exercise, see, if you have to handle the mind from the level of the mind, it is very difficult. It is extremely difficult. Why? Because whatever you resist, it persists. I repeat this. Whatever you resist, it persists. ये नहीं होना चाहिए, ये नहीं होना चाहिए, ये नहीं होना चाहिए. Suddenly that happens. This person should not come, this person should not come, this person should not come. The moment you enter the college, good morning, sir. Whatever you resist, it persists. And it happens totally on the level of the mind. So, how do we handle it? We handle it through the medium of breath. We just let it be and let it go. And today, I think I should guide you through that if you want me to. Good idea? Then we can talk about it more. Once experience it, then we can talk about it more. It's like I haven't had rasgulla or gulab jamun, and I'm asking you how's the taste. You cannot explain it to me. You just say it is sweet, isn't it? So, if you want to explain me the formation and the looks, then it can differ. But if you have to explain me the taste, it will just be sweet. Meditation is also an experiential thing. Few rules to do it. Your hands, can you show me the hands? Turn it around. Keep it on your knees. That's it. So the palm of your hand is facing the ceiling. Okay? This is how should you and second rule is you need to sit straight like a statue for maximum of 1.5 minutes. That's it. You can take a back squat. It's a good idea to take a back squat. As long as the back of the head is in line with your hips. The back of the head is in line with the hips. That is the ideal way to sit. After that, whatever happens in the process, that is fine. But to start off, you do this. So it's very easy. Just to start off, you need to sit straight. Otherwise, it will just be fine. Okay. Third is you keep your eyes closed for some time when I'm guiding. Because if your eyes are open and you are doing this, what is he doing? Suddenly you're more distracted. Huh? And next few minutes, even if the bell of the house rings, somebody comes in, you do not open your eyes. That's it. And the last is, do not imagine, just visualize. For example, if I say apple, the apple has already come to your mind, isn't it? Imagination is what, whether it is cut or not, whether it is apple pie or apple phone. So if I ask you to take your attention to your feet, oh no, I haven't washed them properly today. The nail polish is awkward. I haven't done a pedicure in a while. Stop thinking about that. The mind automatically goes. If I say go to the main door of your, room, wherever your room is, where is the door? The mind has already gone there. Yeah. So let's experiment with this. All right. So let's close our eyes, hands on your knees, palms facing the ceiling. Relax your shoulders, relax your facial muscles, relax your forehead. कंधों को ढीला छोड़ दें, माथे को ढीला छोड़ दें, चेहरे की मांसपेशियों को ढीला छोड़ दें. Breathe in and breathe out. Let us become aware of all the sounds in the surrounding. परिसर में जितनी भी आवाजें हैं, उसके प्रति सजग हो जाते हैं. Sound of distant traffic, वाहनों की आवाज, sound of people talking and walking, लोगों के बात करने की, चलने की आवाज. Sound of animals, जानवरों की आवाज. Sound of the television and the kids playing, टीवी की आवाज और बच्चों के खेलने की आवाज. Sound of the AC and fan in your room. आपके कमरे में पंखे और एसी की आवाज. Sound of your own breath. स्वयं के श्वास की आवाज. Breathe in and breathing out, become one with all these sounds. श्वास भरें और श्वास छोड़ते छोड़ते सारी आवाजों के साथ एक हो जाए. Let us become aware of a physical body. अपने स्थूल शरीर के प्रति सजग हो जाते हैं. This body is a precious gift from nature. Let us honor and respect it. यह शरीर सृष्टि का अनमोल तोहफा है. इसका आदर सत्कार करते हैं. Let us take our attention to our feet. अपने पैरों पर ध्यान ले जाएं. Knees, घुटने. Eyes, जंघाएं. Hips, कूल्हे. The entire legs. Breathe in and breathe out. Genitals and the abdomen. जननेंद्रिय और पेट का निचला भाग. Stomach and the navel region. पेट और नाभि का भाग. chest, छाती, right shoulder, and right arm. Left shoulder, whole of the left arm. Throat, gala, face, head, top of our head. सिर की चोटी पर ध्यान ले जाए. Let's take our attention to the whole body. Whole body. Breathe in and relax completely. Let's become aware of our thoughts. अपने विचारों के प्रति सजग हो जाते हैं. Good thoughts, bad thoughts. अच्छे विचार, बुरे विचार. Do not resist any thought. किसी भी विचार को नकारे नहीं. Just be in harmony with all your thoughts. सभी विचारों के साथ स्वीकृति में रहे. Breathe in and let go. Let's become aware of our feelings. अपनी संवेदनाओं के प्रति सजग हो जाते हैं. Breathe in and let go. You are peace. You are joy. You are peace. You are joy. You are peace. You are joy. You are. Breathe in. Go. Let us become aware of our feelings, if any. Breathe in and let go. Let us become aware of our thoughts, if any. Breathe in and breathe out. Let us become aware of the sensations happening in the body and the surrounding. आसपास के परिसर में और शरीर में जो स्पंदन हो रहे हैं उसके प्रति सजग हो जाते हैं. Breathe in and breathe out. Let us become aware of our body and surroundings. शरीर और परिसर के प्रति सजग हो जाएं. Slowly move the fingers of your hands, the toes of your feet. धीरे से हाथों की उंगलियों को हिलाएं, पैरों की उंगलियों को हिलाएं. Stretch a little, छोटी सी अंगड़ाई लें. Smile a little, चेहरे पे अच्छी मुस्कुराहट बनाए रखें. Take a smiling breath in and breathe out. One more smiling breath in and let go. And slowly and gradually, whenever you feel like, you may open your eyes. Yeah. So if you could type in the chat, how are you feeling? Instead of speaking, it's a good idea to type it. Type it in the chat. Very blank for now, calm, very fresh. Wow. Did you know we sat with our eyes closed for 24 minutes? 24 minutes we sat with our eyes closed. Started at 10:48. बाकी लोग भी टाइप कर सकते हैं if they did it. Rest of you can also type it out. Whatever you felt. Rest free. So while doing the process, if this happened to you, you were not sleeping. It's just losing the body consciousness because you were hearing the instructions. Hmm? In 20 minutes, twice a day, if you do this, no stress can touch you. See, if you say, no, I can't take out time for myself, I'm telling you, I hope you've learned this prayer in your school, no? हमको मन की शक्ति देना, सबने सुना ही होगा, सुना है ना? इसमें एक लाइन आता है, दूसरों की जय से पहले खुद को जय करो. Invest time on yourself. People will be invested in you. See, if 5 minutes you were not able to close your eyes, 6 minutes, hmm, and see how difficult would it be for people around you to be with you. If you cannot enjoy your company, how can they enjoy your company? Everybody is faking so much. Wake up, shake up. Hmm, isn't it? Even if thoughts came, when you open your eyes, I assume you were blank. The process of meditation is deconcentration. The result is concentration, relaxation. Hmm? The mind is just like the sky. The thoughts are like the clouds. They keep coming and they keep going. Does the sky have an inferiority complex? Why is this cloud coming up and it's challenging my existence? The sky knows the clouds will come and they'll go. Thoughts are just like that. You just have to relax. Yeah. So I'm done for the day and I'll be open for questions now. If you have any questions for me, I hope you had a good experience with me. But if you have any questions, I'll be open for that now. Yeah.
Vishesh, I had one question in mind, and
Sure.
that's like you started with that Nadi. I forgot
Shodhana.
the term.
Nadi
Nadi
Shodhana.
Shodhan. Yes.
Yeah.
And before going on for Nadi Shodhan, you told that any pain in the body is due to some stress or some anxiety, and with all those things, stress or anxiety, a particular part gets into pain. So this question, I think, will pertain to many women present over here. In general, my experience is if we take 100 men and 100 women, then the women will have a higher probability of having a lower back pain and knees in the pain in the knees, or maybe nowadays knee replacement operations are so much in demand,
Hmm.
कह लो या फिर whatever you want to say. So that's more with women as compared to men. So is it because of their way of handling the things, or maybe some stress or something? Can you elaborate on that?
So let me give you a theory. So I hope all of you understand there's a difference in theory and something which has been proven as a study, right? So I'll give you a theory about it. I want you to ponder upon it, all of you. See, Earth has a magnetic field, right? North and South Pole. Hmm? So does a lot of other planets have. So there's a magnetic flux that interacts with each other. Hmm? And as human beings, we have bioelectric field. Now, how to handle this? If you go to a mall, you'll see you're too tired once you come back from it. Even if you've not walked that much the way you do throughout your day, you'll be too tired. And also, when you've gone to the mall, you did not want to buy a certain stuff, you bought it. You already had it, but you bought it. What is that? The bioelectric fields of each other interacting with each other and causing a different kind of a flux. So, our body is made up of 5 elements, isn't it? Earth, water, fire, air, space. Everything on this in this universe is made up of these 5 elements. Correct? So when I'm saying these things, space is an element which is untouched because in that space everything exists. Otherwise, air is opposite to fire, but fire also requires air to be there. Water and earth, they're opposite to each other. But otherwise, also the earth to not dry up and not wither off, water is required. And for water to just have a different base to sustain, you require earth. So they're very complementary to each other, but the space isn't. So in our mind also, in our body also, we are 78% water. First thing that happens with us is when there are high tides and low tides, when there is full moon and there's no moon, the mind changes. If you see, there are a lot of sociopath cases or a lot of, you know, what should I say, psychologically hindered cases, schizophrenic cases are more active on the full moon days. That's the forensic study that says that. When I'm saying all of these things, any thought which comes as a vibration, it comes in your space. If it is not taken care at that point of time, it comes in the air element. From the air element, it goes to the fire element, then it becomes a disease. And if it goes to the earth element, it is an irreparable, irrevocable disease. Like what Dr. Nidhi asked, to start off, everything starts with the mind. A lot of us, we say that, okay, no, mind is inside us, it's just the brain. No, no, no. Mind is enveloping the body. Let me elaborate on that as well. So anytime you've been sitting in a room, somebody walks in the room, you do not know that person, but you want to talk to that person. He or she is not that attractive also. आप लोगों को कभी मिले भी नहीं हो, but आपको बात करने का इच्छा होता है. And suddenly another person walks in, you've not known that person, you feel disgusted with that person already. That person is even good looking, but you're just disgusted. What is the difference? The vibes. And as females, vibes are more evident. They have this higher sensitivity to their sixth sense. And those emotions that they capture, they solidify easily over a period of time. And when it gets solidified, it turns into a disease. The idea behind all of this is the ability to let it go. Like ma'am said, lower back is something which pains for a lot of ladies and the knees also. It is connected to somewhat your menstrual cycle as well. But at the same time, a lot of people, it is a common phenomenon nowadays for PCOS and PCOD to be there. And if you analyze or if you go to the root cause of it or whatever it boils down to, it is stress that induces those diseases. Starting from diabetes to hypertension, they're psychosomatic diseases. So the dietary things have caused it, but it's more because of the psychosomatic disorders. They're not able to let go of it. There's a lot of stress in the system. How to get rid of it? Little bit of yoga throughout the day helps. Meditation helps big time. The one that we just did, it helps big time. And for the males, it is they are a little less sensitive and little less sensible, to say that, in terms of getting the emotions out there.
Every wife will have a complaint. एक कान से सुनते हैं, दूसरे से निकाल देते हैं.
No, it is just because they don't hold it onto the system. It is just that they don't hold it onto the system, right? It's just like that. No worries about all of that. Yeah. Any other question? I hope that answered it for you, Dr. Nidhi.
Primarily, if I can conclude, it is mainly stress, and yoga and meditation is going to help.
Correct. Nothing else.
And learning to let the things
Let go.
go.
Yeah,
Yes.
that is one of the most. I see it with my mother as well. It's very difficult for them to let go of it. That's okay. Practice makes.
Yeah, one more
Yeah.
thing.
Yeah.
That again pertains to me. I have my students sitting over here. My ones who are managing the show, they are all my students, research
Correct.
students. So I tell them very clearly that as a teacher, I'm a faculty, I never shout on students. I feel they are adult enough and they know what is good or bad for them. So I just tell them कि इसके ये consequences होंगे. Now it is up to you. I cannot pressurize, I cannot scold.
Hmm.
But somehow, if I look at my behavior, my kids are sitting in front of me. I shout them a lot on them.
Hmm.
I don't know why. I don't shout in the college students, but on my own students, I shout, and I want to rectify that. Can you help me with that?
I'll ask you this small question now. You need to answer it.
Correct. Correct.
So let's say you uh, bought a new pair of spectacles. Do you wear spectacles, Dr. Nidhi? Otherwise,
Yeah.
you
Well,
do.
while I'm
Okay,
sitting
fine,
on the screen,
fine. Yeah, we're fine. So you bought a new pair of spectacles, and suddenly a 1-year-old child doesn't know anything about anything. You've kept it on your sofa, and you're sitting on the sofa, and he comes and he suddenly sits on it and he breaks it. So what do? You put him upside down, kill him for that, persecute him. What do? Or you
no, no,
just
no,
let go
no,
of it?
no. I'm a kind of person. अच्छा है, टूट गया तो अब नया आएगा.
Correct.
Let
है
it
ना?
go.
Let it go.
Yeah.
Correct. And then the second situation is there's a 90-year-old guy in your house, grandfather, grandmother, whatever. They're hardly able to walk. And again, they come and they sat on the same sofa, and your specs were there, and they broke. Then you start shouting at those people. What nonsense is this? What is wrong with you? No, no. You let it
No.
go also, right?
Yes.
In both the situations, can you tell me the common phenomena? Why were you able to let it go?
I guess I got the reason. Not the reason. I am
One
not
of the
attached to those spectacles. If correct me if I'm wrong. I'm not attached to those spectacles. चला गया आ जाएगा नया. But
one
I
thing
think
is
for
this.
my kids, yeah.
Second thing is you're bigger than that situation. You think if it is not happening this way, why is it not happening? See, understand when something does not happen according to your expectations, suddenly the anger has to come out. The
But why does it
acceptance to,
always comes out with my own kids?
because outsiders won't take it after a certain point of time. हर
No,
व्यक्ति
no,
घर
no.
पे बहुत शेर होता है. आप बताओ आपने अपनी मदर के ऊपर चिल्लाया है कभी?
I don't
फॉर श्योर
remember.
चिल्लाया होगा.
नहीं
चिल्लाया तो
चिल्लाया
होगा.
होगा. No, 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 no. See,
कभी तो
there
हुआ
is
ही
a
होगा.
difference between this generation and the generation we belong to. I'm not that very old, but still,
हाँ,
even for a single decade, the generation is changing a lot. I don't
correct,
remember.
correct, correct. So otherwise,
I
you've
may
had
not
some
have
issues with her.
obeyed her. I may
हाँ,
not
correct,
have obeyed
correct,
her, but I never
correct,
shouted.
correct, correct,
Now, days, even my 9-year-old kid shouts at me daily.
correct. Agreed. But there are times in your office, I met the VC in IGDW. So her daughter had done the program with me in DTU. She was studying in DTU, her daughter. So she was, if she tells you to do a certain thing, would you not do it? Would you not obey her?
I will do.
But why?
I'm She is the competent authority of the university. Most of the things I will do,
मतलब
but
अगर
for the
हिं,
things,
हिंदी में अगर मैं
yeah,
बोलूं आपका बस नहीं चल सकता वहां पर.
आप बोल सकते हो, बट कुछ ऐसी भी चीजें होंगी जो मेरा मॉरल नहीं कहेगा करने के लिए. फॉर दैट आई विल स्टैंड कि मैम मैं ये नहीं कर सकती. आई एम सो सॉरी.
वो तो बहुत ही एथिक्स पे नहीं जा
एक्सेप्शनल
रहा हूँ.
केसेस.
हाँ, एथिक्स
यस
नहीं.
यस.
घर पे ना बस चलता है अपना. घर पे अपना बस चलता है. आप देखो ना जहां पर आप सबसे ज्यादा नेचुरल होते हो, वो एक ऐसी जगह है जहां पे आप सबसे ज्यादा अपनापन मानते हो. मैं ये नहीं कह रहा हूँ आपका स्टूडेंट्स के साथ आपका बिलोंगिंगनेस नहीं है, फॉर श्योर होगा. But at a certain point of time, you'll just stop it. Okay, fine यार, तुम अपना जीवन है, देखो, करना है करो, नहीं करना ना करो. बट इधर तो मेरे बच्चे ऐसे कैसे नहीं कर रहे हैं? इधर आना बताती हूँ, ठा.
नहीं नहीं, ठा नहीं होता कभी।
मैं तो थोड़ा एग्जैजरेट करूंगा ही, क्योंकि अपने को तो सब जगह से ठा ही पड़ी है घर पे तो. हाँ, तो लेकिन आप समझ गए ना मेरा पॉइंट ऑफ व्यू, मैं क्या कहने की कोशिश कर रहा हूँ. इट्स
Got
जस्ट
that.
अबाउट दैट. यू ग्रो बिगर देन दैट सिचुएशन. इट्स ओके, रिलैक्स. और मैं आपको बता रहा हूँ, ये बहुत अच्छा क्वेश्चन है डॉक्टर निधि जो आपके पास है. A lot of parents nowadays, what I see, they regret it 20 years later because they
The
see that,
reason for
oh, they get too attached to things, and this, and children are not the same. See, you yourself only said that 10 years the generation is different, right? Everything is changing so fast. Now you were not able to talk to your mother and father in a certain way, but your children are just taking your case left, right, and center all the time. And it's with everybody. It is just not you. Now, the attachment to the mundane is something which brings in misery. By mundane, I mean something which is so changing every moment. But there's a same thing in you that does not change. If you are attached to that, then everything seems enjoyable. It is just like being a lotus flower. Huh? It is in the pond, it is in the puddle, yet it is untouched by it. Are you getting this? How
yes.
does that happen? With little bit of meditation every day. Little bit of meditation. I'm not saying that you become a sadhu and you go to Himalayas. No, no, no. I have not gone there till yet. I go out and just come around and see the hills and love it and come back. Right? It's just expanding yourself, having that room for imperfections with the people whom you feel that they belong to you the most. That is where we do not, accept imperfections. It's just like आपके घर पे पूरा घर एकदम चमकदार होगा. It will be spick and span. It will be very clean. But the place where the dustbin is there, it will be a little dirty. Always. The reason being, you have a room for imperfection in your house. Similarly, in your heart, have a room for imperfection for the people whom you love the most. And see, the anger would just fizzle out. But it comes with a little bit of awareness. It would. A little bit of meditation would obviously help you. 20 minutes a day, nothing more than that.
Okay, you came to this 20 minutes a day. Let me come back to this as well. I have so many questions for you. I can keep you engaged for, 3-4 more hours.
Okay.
20 minutes a day. I could not sit for 20 minutes a day.
Okay.
20 minutes for the meditation that you did now, for 24
Mhm.
minutes. I had to change my body posture on and off because either my knees were paining or I wanted to stretch out my legs,
Hmm.
maybe, straightening the spine. So is it
Correct.
normal? Is it normal?
It's perfectly normal. It's perfectly normal. See, when you go to the gym, are you able to, or if you've gone for a walk, do you do 10,000 steps in one go and then you're on the bed for 7 days? Slow and steady wins the race, right? I know women are already perfect, but practice makes a woman perfect also.
They are never perfect. They don't want to be perfect. That will create a lot of stress if they want to be perfect.
Great.
Have different
So it's okay. You
philosophies.
take whatever time. See, and I would be really honest, Dr. Nidhi. See, your students are out here. They would agree with me also, the students, and you've also been a student yourself in your college earlier. All of you would agree that, even though you have all the books, the material is everywhere, Google has everything, you still require a little bit of guidance. That is why in a PhD they call the faculty in charge as a guide, isn't it? My guide is this, my guide helped me in that. Guide. You know everything. But there's a guide who tells you, okay, uh, let's go like this. It's like having a GPS. You're going from Delhi to Gurgaon and you want to go to Ifko Chowk, so he'll tell you which exit to take. Right? Similarly, in meditation, also you require a guide. It's a good idea to have one. It's just because, see, these questions I am totally up for all of these questions. But as you keep practicing, there'll be different set of questions. There'll be different set of doubts required to have a guide. Yeah.
I'll take up the questions from the chat.
Sure.
Super Lakshmi, she is asking how to manage anger, to let it out or to keep it or control. I mean, there are different situations, I guess she's referring to, because I think there are situations where you need to let it out and there are situations wherein you need to control.
Correct. So, Lakshmi ji, it's very managing anger is first becoming aware of the cause of anger. Anger is a symptom. What is the cause of it? Are you understanding? Cold is a symptom. But what made cold happen? There's a cause of it, isn't it? So to manage anger, you need to understand that. But the primordial reason for anger is basically when things do not happen according to the way you desire them to happen. If you see, it will boil down to this reason mostly. To let it out or to keep it or control it. See, letting it out is something which will make you regret it big time, and controlling it, it will suffocate you. If you want to get work done in the office, it's not necessary to become angry. It is okay to show anger, like we do it at home with our children. You might not be angry with them, but you can show them that anger. If you don't do this, I'm not talking to you. We do that, right? There's small funny things that we do in showing that anger. But that comes with that awareness. Where is the source of that anger? It is inside, it's not outside. The source of anger, like let me tell you an anecdote regarding that. So there was this monk who was, meditating in a boat. Yeah, he's meditating in a boat and he's in a river, and the river is quite, it's basically very, very silent. The river is very, very silent. And he's meditating and he's having a very nice experience. Suddenly, something collides with his boat and he's super angry. What nonsense! I'm meditating. Nobody can see it, or what is wrong with them? And when he opens his eyes, he says that the thing that collided with his boat was an empty boat. So he realizes the anger came from inside, didn't it? But he started blaming it on the outside situations. It's a good idea to become aware of it, because controlling it will make you like a volcano. You can erupt anytime. Letting it out will make you regret it. Why did I say this to somebody? It is about seeing what is the reason of it and letting go of it. Hmm? Yeah. And how much should be the anger? Anger should be the most expensive thing, most expensive thing. And the smile should be the cheapest. Your smile should be cheapest. You make the smile so expensive and you make the anger so cheap. I'm telling you this. किसी को भी आप anger देते हो, you give it to anybody, any Tom, Dick and Harry you're giving anger to. And smile. Anybody in your office also, if he or she looks at you and smile, आज इसको मुझसे क्या काम है? Let's do the opposite, isn't it? Make your anger the most expensive. And how long should the anger last? If at all you are angry, it should be like a line drawn in water. Not really long, isn't it? Good idea to do that. Sometimes we can't change someone and we can let it go as well, because if we try to let it go, it causes stress. How can we handle this situation? I'll tell you a funny fact about this. The mind is such an intelligent thing. Instead of itself, it wants to change everything else. ये मन इतना चालू है क्या बताऊं, अपने अलावा सब कुछ बदलना चाहता है. You want to change the person. Yeah, I'll complete.
Please complete. Yeah.
You want to change the situation or you want to change the person, right? That is never under your control. Acha, tell me, have you overeaten? ज्यादा खाना खाया कभी, मतलब जरूरत नहीं थी लेकिन खा लिया, खा ही होगा, काफी बार हुआ ना। और ये एक से ज्यादा बार किया है आपने, और अपने आप को बोला कि आगे से नहीं खाऊंगा, करा है ना, फिर भी किया ना। आप अपने आप को नहीं बदल पा रहे हो, आप दूसरों को क्या बदलोगे? आपके माँ बाप आपको इतने सालों में नहीं बदल पाए, उन्होंने बोला बेटा ऐसा नहीं है, आप फिर भी वैसे ही। अधिकतर चेंजेस आ गए लेकिन काफी चेंजेस तो नहीं आए जो उन्होंने डिजायर रिजल्ट चाहा था। See, we are exercising our control on things which we cannot control, but we are losing the control which we can control. So you can change the perspective of your mind, you can change your emotions, you can change your stress levels on your own. But what we want to change is the situation that is causing it. Situations will keep coming back again. People will keep coming back again in the same way. If you let go of that person or just avoid that person, ignore that person, I'm telling you, that kind of a person will again come back in your life till the time you move on with it. Because I'm telling you, life is the biggest teacher. It keeps repeating the lessons until you get it. It's the most patient and the most moving on really is what is moving on really is letting go of it. You're not affected by it. How? By having no dislike and like. Why? Because like and dislike bound you. For example, let's say you dislike Karela and Dr. Nidhi invites you for a sumptuous meal at her place. Come, come, come. And she makes Karela. What nonsense! Or who calls somebody on at her place and gives Karela? In dislike, now I'm not going to her place. And like is paneer. So every time you get paneer, wow, I'm happy. So haven't you bound yourself? It's like if you've studied limit, lower limit and the upper limit in an equation, you just bound yourself in that equation. You're not tending from infinity to infinity. You're tending from 0 to 1. That's it. Either it is this, either it is that. If none of this is there, then you're miserable. Letting go means having preference. It's okay, Karil, fine. Paneer, fine. I'm okay with both of them. See, we have created boundaries around ourselves, haven't we? This is how I like it, this is how I don't like it. And somebody asks you to come out of that boundary, you are just shaken up. You're just taken aback. It's like that. Understood? Now, how? See, I have only one method for that meditation. Trust me on that. I've been doing it for 15 years. So I have found a different ball game out of it. Yeah. Because this knowledge also which I'm sharing, it will have an impact, it will have an application when you meditate, when you make yourself bigger. It's like you're like, let's say, there's a little bit of amount of water in a bucket. Then there is a pond. If I put a pebble in the bucket, it will have some ripples. If I put it in a pond, it will have some ripples. If I put it in a river, would you even see the ripples when the river is flowing? In an ocean, the journey is from becoming an ocean from the water in the bucket. That happens through meditation. It's like a trajectory, projectile motion. It comes like that.
Sir, on this note, we have another question that how much time, days, maybe it takes for a beginner to do actual meditation?
I'm sorry, I don't have a straight answer to anything. So for people, it happens like this also, or it takes some time also. For me, it did not happen. I did not realize the importance for it for 1.5 year. But the only thing was I continued doing it. After 1.5 year, I thought, oh man, this is phenomenal. I've seen people having it in the first 10 days itself. It's about, if you want to ask me this question, that how long do I have to do it? It's like cleaning your home every day. Do you prefer to clean it every day? So you clean yourself, clean your mind every day, right? Do you charge your phone every day? Do you charge yourself every day? Which time is most useful to meditate? Any time when you're empty stomach. Any time. Don't say no, I'll get up at 4. वो एक सपना ही रह जाता है. 4 बजे उठूंगा, फिर ध्यान करूंगा, फिर कुछ तो होगा, ब्रह्म मुहूर्त निकलेगा. नहीं. आप जब खाली पेट है आप बैठ जाएं. खाली पेट का अर्थ क्या है? If you've had your breakfast at 9 a.m., 11:30 you can sit to meditate. And where can you sit to anywhere where you can just be calm with yourself. I have done it while traveling. I've see before the lockdown happened, I used to travel frivolously. So in a year, I've taken 120 flights. That's huge. 365 days. So I should meditate while traveling also. I'm in a flight, I'll just meditate. It's fine. You can do it anywhere. Yeah. Yes, Dr. Ndi, I paused you in the middle. You had to say something.
No, it's all right. I got the answer.
Okay. Okay. So I think
Any
I've
more?
answered most.
Yeah. Any more questions? We'll just ask a quick, chat if somebody has any question. I think Palak, you can wind up there.
Sure, ma'am. Thank you so much, sir, for gracing this event. We really had a magical moments in so many, and I can keep on thanking you enough and so much. Thank you so much.
Thank you for inviting me. Yeah. Have a nice day,
Thank
all
you,
of you.
Vishesh. Thank you. Thanks.
Our next session will start from 12:15 p.m. We request you to please join right after. Thank you.
Hello, good afternoon, everyone. Good afternoon, sir. Tanveer, sir, can you hear me?
Yeah, I can hear you. Good afternoon.
Yeah, yeah, good afternoon, sir. So, please check if you are able to share your screen or not. We
Sure.
will start our session at 12:15.
Yes. Yeah, is my slide visible? I mean, are they visible?
Yes, sir, your slide is
Oh,
visible.
okay.
Yeah.
Great.
So participants will join up to 12:15.
Sure. I can. Tanveer, actually, I was
Hello, sir, am I audible?
Yeah, I can hear you.
So can we start our session now?
Sure, it's your choice. I'm ready.
Thank you, sir. Thank you for allowing us.
Yeah.
Good afternoon, everyone. Myself, Anushri from Indira Gandhi Delhi Technical University of Women. For this session, we have Dr. Tanveer Ahmed from Bennett University with us. Dr. Ahmed is PhD in Computer Science and Engineering from IIT Indore. He has completed his MTech and BTech in Computer Science and Engineering from Guru Gobind Singh Indraprasth University. His research areas are machine learning, data analytics, cyber physical systems, man-machine systems, application in machine learning in psychology. Dr. Ahmed has published various research.
Yeah, Anushri, Anushri, your voice is kind of breaking in the middle.
Okay.
And now it's fine. I can hear the background thing. Yeah.
Okay. He has also developed a trading protocol suite to trade in various sectors of the market by using algorithm. Today, he will be delivering a session on pattern finding, distribution, anomaly detection. So I request Dr. Ahmed to address our attendees.
Okay, thank you, Anushri, for that wonderful introduction. So hello guys, my name is Tanveer. So I'll be your instructor for this session, and I'll be discussing a few things on pattern finding, analyzing distributions, and of course, anomaly detection. Just to give you a brief about myself, okay, I know Anushri kind of was saying something, but her voice kind of broke in the middle. So I mainly try to apply all the ideas that I'll be discussing. In fact, some of the ideas that I'll be discussing today with you guys. So I apply these ideas in two places. I like psychology, human psychology. I did my PhD, of course, in the intersection of computer science and psychology. And I also try to apply these ideas in the financial sector, the derivatives market, the equities market, cash market, currency market, whatever market you want to call it. Of course, I have a few case studies even from the financial sector. So I'll be discussing about patterns and distributions and so many other things. So I have a few case studies even from the Indian, let's say, stock market. Some of you might know it by the name Nifty 50. Those of you who deal in it. I might be giving some of the people, in fact, I can see there is around 80, 85 people here at this point. So some of the people I'll be giving, in fact, there are 90 people now. So I'll be giving some ideas, of course, using statistics, how, in fact, and using probabilities, how you can even look to trade, for instance, in the markets. So without any other delay, let me come to the point now. So first of all, distributions. I'm sure you must have heard about distributions. A very, very famous tools to analyze the underlying dynamics of data. In fact, the first thing that we all do is we check the distribution of data. Distribution conventionally, there are two different types. First of all, we look for data distribution, and from data distribution, we can automatically deduce probability distribution. And that's once again, well, same thing for practitioners. In theory, of course, they're different. One of the very famous tools to analyze distributions and to find anything of interest is histogram. The very, very basic stuff, very, very basic stuff. I'm not even getting down to the bada distribution, the big distribution. So very basic stuff. Let's start with the basic stuff and let's build upon it. So histograms, we often use histograms to analyze distributions, look at the data. See, data generally is what? Numbers. Numbers, I always tell my students that there is always a story in numbers. You just have to be smart enough, or you just have to be experienced enough to understand that story. Two things. Yeah, so you are very, very smart, or you are experienced. You worked hard in your life. So histograms is once again very basic stuff. Histograms, very, very simple topic. You club data together and you check out this frequency of data in a particular range. For instance, let me show you this very simple example taken from a textbook. You have some data, in this table 2.3, for instance, this is taken from a textbook. You club data together, you get frequencies, and then you plot those frequencies. Now, distributions, they're of two different types, first of all. Okay, distributions are of two different types. First one is parametric distribution. The other one is non-parametric distribution. Now, let me first of all, let me share my whole screen. That will be a good idea because I have a few demo. Okay. All right. So I am sharing my complete screen with everyone. Okay. So let's see. This is something. Okay. So I have some, let's say, data values here. Okay. This is my MATLAB window. I'm sure you guys know this is MATLAB window. So I have my data values here. Okay. This is my data. As I said, histogram, I'm using histogram to check out the distribution. So I just type hist from, I'm passing the number of intervals is 30. And I get a distribution of my data like this. So this is the distribution of my data. Now, there are a few things here. For instance, let me jump to my here. I will be shifting, okay, in this session, I continuously shift from R to MATLAB and MATLAB to R. Don't focus on the programming language, just focus on the plots. Just focus on the plots. Sometimes, for instance, sometimes you have a distribution that looks like this. This kind of bell shape, no? Kind of bell shape. We'll get down to bell shape and normal distribution. I'm sure you must have heard about normal distribution. So kind of bell shape. Whereas the distribution, this distribution is not normal at all. Oops. This, okay. The two distributions are completely different. You can clearly see that the two distributions are completely different. Of course, data values are different, and that's why the distributions are coming out to be different. Here in this figure, the one that is not in blue color, the normal white color, grayish color bars, looks like a normal distribution, whereas the other one looks like a mixture of two normal distributions. Again, we'll something we call it a Gaussian mixture model. But anyways, we'll not discuss GMM today. On the same topic, okay, in this front, as I was talking about, there are two different types of distributions: parametric and non-parametric. Parametric distributions, first of all, are those distributions where there is an assumption, on the underlying shape. For instance, we saw that grayish color distribution. The assumption there was everything is kind of, the data kind of is following my normal distribution. So that was parametric. There is an underlying assumption here. Non-parametric, on the other hand, it's like what I call, it's like a dialogue from Google. Let the data do the talking. So non-parametric distribution, there is no assumption of that, there's no assumption at all. You let the data do the talking. You are not trying to explicitly fit any kind of pattern or any kind of shape to your data. No, you are letting the data do the talking. That forms a part of your non-parametric distributions. And of course, analyzing non-parametric distribution, you just saw histograms is one of the easiest ways to analyze non-parametric distributions. No assumption of any kind whatsoever. Now, moving on. Now, types of parametric distributions. My God, there are so many different types of parametric distributions. So many. Yeah. Any question? Okay, so guys, one thing at my end, you can see my screen. At my end, I am looking at my slides. I am not looking at the chat box. So if there is a doubt in anything, then you please unmute yourself if you can, or if you can unmute yourself, then please speak up. So first of all, we will build upon the basics.
Have any question from the do we have any question from the participants? No, sir.
All right. All right. Thank you. Thank you, Anushri. So let's move on to parametric distribution. Of course, as I was saying, there are thousands of distributions, parametric distribution, normal distribution, log normal distribution, Weibull distribution, Rayleigh distribution, Poisson, Bernoulli, so many distributions. Nobody can study all those distributions in like 2 hours. It will take like 1 month or maybe 2 months if you want to study everything. That's why I just took down the basics. Of course, I will show you something how you can play around with the idea of distribution and how you can find a few things. But I'm going to start by building some very foundation. I know most of this will be very basic stuff, so it's just a revision for the next 5 minutes. First of all, I'll be revising random variables. Random variables, once again, is nothing but a function from the sample space to real values. Now we're getting into, since we're talking about distributions, so naturally we're in the domain of probability. So we are looking at probability theory as well. So probability theory, if you remember that there used to be a sample space S, for instance. Let me see the number of participants. I can understand 94 participants are there. So let me once again stopping in the middle, and I'm sharing my not the whole screen. I'll be sharing my PPTs because I know they will be lag. I have experienced this many times. They will be lag, so I have to share my PPT window. Once again, it's sharing my host. Hold on and share. Okay. I'm doing this because I know there will be lag. If I write something down with my pen, I know I've experienced this, there will be lag. Okay, so let's say you have a sample space. Sample space, you have certain elements. Okay, this is, for instance, you're rolling a 6-face die. So 1, 2, 3, 4, 5, 6 are the possibilities. So these are some of the elements. Sample space, for instance, groups your elements together or your element together. And it maps down the elements to a number, a real number. So it's a function random variable which maps the element or elements of a sample space to real values, which I'm sure you guys know. So for instance, you have this random variable. It's like coin. The experiment here is coin toss. Sample space, of course, we can get heads or a tail. X denotes the number of heads. I'm saying my random variable X is number of heads. So therefore, it can take on two values, 0 and 1. Similarly, for 2 coin tosses, once again, the same idea. Here, in this case, my random variable can take on only 3 different values. Representing the entire idea in terms of graphs, this, for instance, this figure on the left that I've drawn by hand, your sample space, there are some elements, you grouped some of the elements together, and all of these elements are mapped down to a real number. The figure on the right, let's say the figure number 2. Once again, the first oval, this is my sample space, S or pi, certain elements. I'm grouping those elements together. In fact, I'm mapping those elements together onto a number. And this is done by my random variable, my X. So this was my random variable, very quick revision. Of course, there are 2 different types of random variables, discrete and continuous. Discrete means, once again, as we saw, something that is countable. For instance, going back to the figure, in fact, sorry, going back to this example, my random variable could only take on 3 different values. Something that is countable. It could be like trillion, maybe trillion. We cannot count it on hand. Nobody can do it. But a computer can count it. So that's the idea. Something that you can count, something that we can measure or compute comes down to discrete variables. Something that we can't, on the other hand, some things that we can't. For instance, theoretically, between 0 and 1, theoretically, and if we are in continuous domain, there are like infinite many numbers. When we are in discrete domain, so let's say there are numbers towards 0 and 1, there could be something like 0.5 here or 0.4 or 0.2 or 0.005, whatever be the step size. But still those numbers are countable. Here in the continuous domain, there is nothing is countable. And here my random variable can take on any value in a certain range. It cannot converge down to a single value. It takes on values in a certain range, which we call as interval. So those variables are your continuous variables, continuous random variables. Then you know the expected value, the mean value, very simple, very old idea, very central idea in science, probability theory, scientific investigations. So many, since we have been talking about distributions, anomaly detection, and so many other things. So we can have a situation where, for instance, distribution of data looks like this, something. something very bad. Now we want to make out some sort of a, we want some sense of certainty in this uncertain world. So what is that sense of certainty? That sense of certainty is given by my expected value. Although it's like, if I abuse the terminology, or I know I'm abusing the terminology here, you can think of it as your mean value. Although mean value is nothing new, but it gives you, yes, the sense of certainty in a world full of uncertainty. And this expected value is actually the core behind a lot of scientific principles. For instance, Monte Carlo simulations. Everything is based on expected value. Particle filters, I'm sure some of you must have heard of it. Particle filters, everything is based on expected value. Expected value is like weighted sum. Weighted by what? Probabilities. Since we have expected value, we also have variance, which is nothing but gives you the idea of variability or the amount of variation in your data. Since we'll be talking about distributions, analyzing distributions, looking at distributions, so it's important to study. In fact, it's important to recall, in your case, variance and expected value. Variance gives you an idea of the amount of variation in the data. Expected value gives you the sense of certainty. Next point is probability mass function. Okay, PMF and PDFs. In distributions, you will find PDFs, PMFs everywhere, wherever you go. That's why I'm taking some time, 5 to 10 minutes to analyze, to recall the old concepts. So PMF, by the way, is a function that gives you the probability that a random variable will be exactly equal to something. Okay, going back to this figure, once again, going back to this figure. This figure, the one on the right side, the second figure that I've marked here. The first oval, you can see the oval is my sample space. The second oval, all 0, 1, 2, the middle one, the numbers here. These are all the numbers that my random variable can take. Okay, 0, 1, 2. Now the thing is, let's say we want to compute what is the probability that my random variable x is exactly equal to 0. Exactly equal to 0 means there is no heads. We're talking about no heads. If we are tossing 2 coins and we are trying to compute no heads, naturally, we all know this is like probability is 1 by 4, going by the naive definition of probability. In fact, following the frequentist approach, we all know it's 1 by 4. So this kind of a mapping, this is once again a kind of mapping. This mapping is given by your PMF. So in short, very short, sample space to numbers, random variables. Numbers to probabilities, PMF, probability mass function. Very, very short, very quick revision of PMF random variables. If we are revising things, so let's quickly revise this Bernoulli distribution, and then we'll jump to main PDFs, and then we'll look at demos of a lot of things. So Bernoulli distribution, once again, very simplest of distribution. Here my random variable, for instance, can take on only values with some probability. For instance, let's say value 1 with probability P and the value 0 with probability 1 minus P. So only 2 values. Something, for instance, tossing a coin, heads with probability something, let's say P. Tails with probability something, 1 minus P. In the real world, the coin might be biased, it might not be biased. I mean, I don't know. So that's why P and 1 minus P. Simplest of distributions whatsoever. Next is binomial distribution. Once again, an extension of your Bernoulli's distribution. Here you are looking at, like, the idea is to find out, once again, let's assume we are tossing the coin k number of times. In this case, let's say n number of times we're tossing the coin. And out of those n tosses, we are looking for exactly k heads. We're looking for exactly k heads. Somebody wants to compute the probability, okay, out of n tosses, what is the probability that I'll get exactly 10 heads? Same thing. Let's say India is playing Australia, a cricket match, for instance. What is the probability that out of 100 matches with Australia, India will win exactly 60 matches? अब इसके लिए what we have to do here is we first have to compute the win percentage or the winning probability of India. Let's say it's 65 to 70%. Let's make it 65%. 100 matches India is playing against Australia. Out of those, we are looking for exactly 60 wins. So this is the PMF. That's how we can compute the probability. You just plug in the values and you compute the number. And it is this number, if you get down to it, just speaking from the top of my mind, the number might be like 0.007 something. Some of you might say it's a very less number, it's a very small number. See, in a world full of uncertainty, India is playing Australia, and out of those 100 matches, you're looking for exactly 60 matches, 60 wins. Exactly. It could be 58, could be 60, could be 65, could be 70, could be 80. We don't know. And we are here in this question, we are asking exactly 60. That's why the number will be very, very less. Should be like something like greater than 60, less than 60 or something. Then, yeah, we will get some good numbers. So this is binomial distribution. And I have here shown you the plot of the PMF, the probability values. What different, N values and P values. This here, by the way, is your K. Okay, on this x-axis. Assume for the time being, looking at this graph, assume that we are looking at this red graph or red line wala graph. Assume the probability of winning is 50%. And let's say you're tossing the coin once again, getting ahead is 50, getting ahead is 50. You're tossing the coin 40 times, and out of those 40 times, you're looking at these many K number of times. K number of times you will get a heads. If you compute the probabilities, comes down to, and if you plot it, you can see the figures. This is an example of binomial distribution. Now coming down to the next discrete distribution, Poisson distribution. Once again, very quick revision. Poisson distribution is used to model something which occurs at certain events. Certain intervals, not events, certain intervals. For instance, number of accidents in 1 year, number of earthquakes in 1 year, number of emails you receive, number of crashes. You all have seen servers crashing. So model something that is happening with regular event, you use this Poisson distribution. And of course, the way you compute probability is using this PMF, the one that I've shown you. Now coming on to the next domain. So far we were in discrete domain where things were countable. Now let's get down to continuous domain. Here, as I said, theoretically, my continuous variables, any continuous variable can take on any number of infinite values. So here we don't use the idea of PMF. We use the idea of PDFs. PDFs, probability density functions. What is probability density function? Probability density function, once again, quickly revising stuff, gives you an idea of probability that a random variable can take on any value in an interval. For instance, what is the probability that my random variable will take on any value between 40 and 45? So this curve here shows you the PDF. My random variable can take on any value between 40 and 45. That means I'm talking about this small range. Anything, this, if you recall, probability often referred to as area under the curve. I'm assuming you guys are, because this is kind of advanced, so I'm assuming that you guys remember some elements. So this area under the curve. So PDF gives you the probability that a random variable taking on different values in a continuous range. And of course, this f of x is my PDF. It tells you the probability that my random variable can take on any value in a given range. We'll see how we can apply these ideas in the real world. Okay. In of course, since we are talking about distribution, so let me start with very basic distribution, uniform distribution. Now, uniform distribution is like your unbiased thing, fair word. Everything has a fair chance. In real world, people think, everything is fair, but we all know through experience, okay, real world is kind of biased. Not everything is equally likely to happen. If, for instance, if you are living in North India, and if you're going for lunch, you're expected to get, chapatis. Or if you're in South India, you're expected to get, something made out of rice. So real world is kind of biased towards something. Uniform distribution is not biased at all. It's not biased enough. Here, my random variable can take on any value in a particular range with equal likelihood. For instance, anything between A and B in this figure, any number, anything in between has an equal chance. Chance bole to you can assume chance like this height. Okay, by the way, this my density value. This follows my density value. This height. So everything is equally likely. Moving on, the very famous distribution, normal distribution, the bell-shaped curve. Every very famous. Every field has its applications. In fact, every field has an application based on normal distribution. Very famous distribution, the bell-shaped curve. Even in movies, they show bell-shaped curve. They use bell-shaped curves. And in fact, in one of the news channels, I also saw some of the analysts, news wale analysts, they were using bell-shaped curves to monitor when will coronavirus be completely removed from the world. I don't think they understand the behavior of the models and probability distribution. That's why they said by September or by October 2020, everything will be gone. But we all know what happened. But anyways, coming to our part, this curve, once again, bell-shaped curve, central point is your mean value, symmetric around the mean value. Furthermore, the amount of data that lies near this mean value is maximum. The PDF is this, which I'm sure you guys know. Written as this is normal distribution is written as this. What we will be using today in our demonstrations and in our, the other things that we will be discussing today is based on these properties. So that was kind of a very quick revision, but now let's get down to the real stuff. Okay, so let me start now. Now I will go a little bit slowly because now comes the interesting part. That was so far all about revision. Now let's assume since we are in academic environment, let's assume for the time being that we are talking about marks of student marks, let's say. And let's say we have a class of 100. We know that some of the students will perform poorly. I mean, we don't know for certain. They could perform poorly. Some will perform kind of in a better way. Some will be average. Some will be better than average. Some would be really exceptional. For 90+ percentage. Assume this is like increasing order. Okay, the left to right increasing order of marks, and this is like on this hand I have my frequency, and the use case I'm assuming is I have 100 students and marks of all those 100 students, and I'm plotting the frequency of all those marks. Here exceptional, very bright students, bright. In the center we have around the average students. Here we could have people, in fact, students who are a little bit weak. And generally, if you guys come from an academic setting, you know what I'm talking about. This is how we kind of look at students. At some places, they follow a normal distribution behavior. At other places, they say, no, we don't want to follow a normal distribution behavior. You can choose your own pattern. Now, if that is the case, now correlating this idea with these properties, if that is the case, of course, a normal distribution also has a mean value. And there will be some variance. Okay, variance, as I quickly went over that slide, variance gave you the amount of variation in the data. You take the square root of variance, you get standard deviation. The variance often written as sigma squared. Take the square root of it, you get sigma. Now, let me clear up all the ink on the slide. Now comes the interesting part. And this is what we will use. In fact, this is what we will be using, and this is what you will use in your in the real world. Most people use the same idea. The idea is this: from first of all, this is a PDF, and if you, I never discussed these properties of PDF because I thought this when I asked. So people here, they are from an academic background, they're PhD holders, and some of them are like PhD students. That's why I never went over the basics, and I quickly went over those PDF, PMF, random variables. But since this is a PDF, the area, the whole area under the curve is 1. And this is all, I think we all know, sum of the sample space for P of S is 1. So assume all the elements, all everything, sum is 1. In fact, the area under the curve, since this is continuous domain, the area under the curve is 1. Assume 1 means 100%. In terms of data, assume that on the x-axis I have my data values. Assume on my x-axis I have my data values. And under this curve, whatever I have, whatever data value I have is under the curve. Now, going one standard deviation away from the mean position, that means sigma, sigma. If I go like one standard deviation away from the mean position, I will be able to cover 68.2% of my data. 68.2%. 68.2% of my data values. In other words, the area here, if we talk about, once again, if we talk about probability, not data, if we talk about probability only, this area, the one that I'm shading now, this will be 0.68. If I go 2 standard deviations away from the mean position, that means if I select, let me choose a different color. Let's say this color. If I go 2 standard deviations away from the mean position, that is, if I use this, if I include this side and this side, that means I am adding this color, this blue color, plus I am adding the area in my red color. If I do that, then I am covering 95.4% of the data values. In terms of probability, the area under this portion that I'm highlighting in color now, red color, till here to here, this whole area will be 0.954. 2 standard deviations away. This is theoretical. And once again, the third point says if you go like 3 standard deviations away from the mean position, you cover 99.7% of the data values, or the area under the curve will be 0.997. Question is, does this thing hold in the real world? And the answer is absolutely. To some extent, yes. You might not get close enough numbers, but you might get something. For instance, let me show you a demo now. For instance, I am going to stop sharing this screen. I will share my full screen now. For instance, okay. I have this data values. Okay, I have this thing I have opened. I'm sure you can see this. Let me double check. Okay, yeah. So this is, as I said, one of the areas I work in is the financial sector. So this is my, once again, stocks basically. This is my index. This is my Nifty index. This is my Nifty index, and you can see the market if you people know. I mean, some of you, I'm sure some of you know. The market is increasing. It's not even going down. I don't know what is happening. Okay. Talking about whatever we just discussed. Okay, data values. Let me take the data values. Okay, all the data values, and I think I have all the data values here. So I have paid subscription, so I can do anything I want. So let me remove this thing. Okay, so I'm focusing on the close value. Only on the close value. Yeah. Okay. So I've taken the data of the market, the stock market, the Nifty 50 index from 2016, 30th of 30/11 2016. That means 30th of November 2016. Almost 5 years. I'm focusing on the close price, just the close price. If I do that, let me close. I'm just loading the data very quickly. I'm focusing on close price. Okay, now let's check the distribution of this close price. Okay, see the distribution comes out like this. The distribution of the index that I showed you came out like this. And this is, by the way, I think Nifty Bank. Okay, Bank Nifty. This is Bank Nifty. Once again, one of the indexes at NHC. So if you check out the distribution, it comes out like this. Simply the closing value. That means at 3:30 every day, what was the index's value? Or you can index's value, you can assume it to be like stock up price. What was the stock's price at exactly 3:30 every day, Monday to Friday? And if you check the distribution, it comes out like this. Now, what I'm doing is, what I've already done here is in this Excel sheet is, I have taken the percentage change. You can see this column F column. I've taken the percentage change. क्या किया मैंने? I took this guy and computed percentage change for every day. For every day, I computed the percentage change, and it is nothing but this. The numbers that you can see here. Percentage change by how much of a margin? By how much percentage did on every day did my stock rose or went down? And now I'm checking the distribution of my percentage change. And if I do that, I get a figure that looks like this. I'm just looking at percentage change. Remember, in fact, recall. Previously, when we looked at the distribution of my close values, it came out like this. However, as soon as I checked the percentage changes distribution, I computed percentage change and I checked the distribution, it came out like this. Kind of resembles our normal distribution. Of course, there are a few outliers which we'll get to. You can see that there is one bar here beyond -15, very close to -10. Beyond -15, this is, if I remember correctly, or around -10, if I remember correctly, this was during coronavirus times, March 2020. Markets were dropping like crazy. Crazily, I mean, markets were falling. If you can recall, even in the news they were saying a lot of things. So these are those things. Kind of look like our normal distribution. Now let's come to our statistical properties. Mean value. Let's check out the mean value of my total, of my percentage change, basically, which I'm storing in my variable total. So it's around 0, which we can correctly see from this figure. The central point is around 0. Let's check out the standard deviation. It is around 1.6. Yeah, it's 1.6. Standard deviation is 1.6. Now the properties that we studied said mean plus minus 1 standard deviation. It covers 66% of my data. So if I look in this figure, focusing on this figure, if I look at somewhere around 1.6, in fact, minus 1.6, standard deviation is 1.6, mean is 0, approximately 0. So mu minus 1 sigma, that is minus 1.62 plus 1.6. It should cover my 66% of the 68.2% of the data. If this was a normal distribution. So I have already written the code here. And paste it. Okay. If I do that, if I check it out, it says 82.36% of the data is between mu minus 1 sigma and mu plus 1 sigma. So clearly, this points out to two things. First of all, this is not a normal distribution. Although it looks like one, it's not a normal distribution. We have to really check it out using some normality tests, which we'll not discuss today, how we can check out if a distribution is normal or not. And there we can always check out QQ plots, which we will not discuss today. However, since it looked like a normal distribution, and of course, normal distribution is the behavior that most people in finance, they base their models on, that everyday returns, everyday percentage change is following a normalish behavior. So first of all, we check it out, doesn't follow. 68.2%, data value should be between mu minus 1 sigma and mu plus 1 sigma. Here we can see it's 82%. Let's check out the last two values. Mu minus 2 sigma and mu plus 2 sigma. For mu minus 2 sigma to mu plus 2 sigma, I'm covering 95.35, which is very much close. Theoretically, I expected 95.4, but it's close. Similarly, mu minus 3 sigma to mu plus 3 sigma, the amount of data values that I should be able to cover was 99.2%, 99.7%. And here I'm covering 98.2%. That's okay. Because we know now it's not completely normal distribution, although it looks like a normal distribution. So this is so far, whatever I discussed was so far based on the idea of parametric distributions. The broad category of distribution is parametric. Here we kind of assume, see, we're looking at this percentage change distribution of stock value, or sorry, this bank Nifty index value. I assumed the percentage change to follow normal distribution. But really, does it happen? I mean, we cannot assume anything in the real world. We have to let the data do the talking. And that's why the field of non-parametric distributions, it came into picture. And as I said, histograms, in fact, the figure, the case study that I discussed was based on histograms. Very famous tool, very famous non-parametric tool. Furthermore, we also have kernel density estimation. Kernel density estimation, what we do is, once again, we try to fit multiple kernels over the data. And then we try to find out the best possible fit. For instance, let me jump here. Okay. This is once again my MATLAB. Now I have some data value which I've stored here in A. My A is a variable and it has some numerical values. These are some of the numerical values. Once again, this is Bank Nifty from the financial sector. Okay. So some data values I have. I check out the distribution using, histograms for the data values. It comes out like this. Now let me choose KS density, kernel density. Non-parametric way of working with distributions. And if I do that, I get a figure like this. So let me take a screenshot and let me open up my paint window so that you guys can make out side by side what is happening. So this is my kernel density, and also let me once again go with this and print screen this, and very quickly Control Z, Control V, and that's it. Okay. So same data, two different ways of looking at distributions. First one, sorry, the second one, this one. The second one, this one. Histograms. Very, very famous, very, very easy way to look at things. This, on the other hand, once again, you can see this is using kernel density estimation. We will not study kernel density estimation because it will take one entire lecture on kernel density estimation. How do they do it? How do they fit different kernels? What is meant by width? But just try to understand that there is a way through which we can let the data do the talking, and we can, without fitting any of the existing distribution, we can just look at the distribution in a non-parametric way. Furthermore, you can see kind of from the two figures, they're not normal. They don't follow any of the previously defined patterns that we have seen. It is following a pattern of itself. So that's where kernel density estimation as well as histograms are important at looking at stuff. Now, looking at, once again, going back to my slides. Now, applying these ideas in practice, as I said, in fact, we took the case study of Nifty 50 and we saw the daily returns. हमने देखा daily returns. Every day, percentage change, if you recall, this histogram, if you recall, the daily percentage change. So this is something that we will use here in how we apply things in practice. Now, this was daily, by the way, this was daily. Now let me go to weekly. Weekly, what I'm doing is, I'm going back to my original this thing. Okay, so this here is a graph. Let me use a line graph. Okay, so this is a line of how the Nifty 50 is behaving on a daily basis. Okay, on a daily basis. Now what I can do is I can group together all the values and I can check out how Nifty is behaving on a weekly basis. So let me go weekly. And this is the way Nifty is behaving on a weekly basis. You can see the drop here. This drop came during the coronavirus time. And after that, I think since July or maybe May to 2020, or it's in March 2020. After that, I mean, Nifty is increasing and increasing and increasing. I don't know what is happening, but it's making high and high and high. It's going higher and higher and higher. Something is happening. Now, following the same ideas, once again, following the same ideas, you saw I computed the percentage change and then I plotted the histogram, the distribution of the percentage change, the daily percentage change. Following the same idea, this time I'm looking at weekly change in Nifty. That means Monday, let's say it was 1000. I'm checking next Monday, what is the percentage change? For instance, if now next Monday is like 1100, so the percentage changes 1%, not 1%, it's 10%. And then once again, I am checking the distribution of the percentage change. Looking at the distribution of percentage change, and it's coming out like this. Now let's get down to business. Okay, let me open up my pen. Now let's get down to business. On a weekly basis, this is the distribution of my, let's say, the Nifty 50, the Indian Nifty 50. Now what can we do with it? Let's use common sense. As I always tell my students, when everything fails, common sense will never fail. Let's use common sense. I know this doesn't look like a normal distribution. I know this doesn't look like any parametric distribution. Although it looks close to normal distribution, but it's not. So what can we say? Okay, I can see visually, once again, without even computing any number, visually, I can see majority of my data is between -5 and +5. On a weekly basis, by the way, on a weekly basis. On a weekly basis, Nifty, the percentage change is between, majority of the time is between -5 to +5. Monday to Monday, by the way, Monday to Monday. On a very few, in fact, I won't call them rare, but let's call them few. On few occasions, the Nifty index actually went beyond +5% or -5%. On a weekly basis, once again. They can always compute the frequency of numbers between -5 and +5, which I'll show next. Okay. The majority of the numbers are between -5 and +5. So what's the use? So for some of you who knows about option selling, you can do option selling -5%. Beyond -5%, you can always sell. For instance, if Nifty is at 1,000, you can sell like -5% one option, put option, or if you want to sell, you can sell call option, which is beyond +5%. Okay, that is something that what most institutions do when they do it, when they are trading statistically. This is called a statistical trading. You're looking at numbers, and then based on those numbers, you're computing probabilities, and then based on those probabilities, you are kind of making a decision. In fact, your machine, today's world, takes a decision. What are those numbers? So let's look at some of those numbers. I have those numbers here in my RStudio. Okay. Once again, going back up. So I have some data. I have some 250 weeks wala data. 50 weeks, let me double check. Yes, 250 weeks. So you can understand 1 year has 52 weeks. So this is approximately 5 years of data. Now, let's look at something. Let's look at how many times, in fact, what percentage of, okay, first of all, let me just show you one row. This row, look at this row number 30. This is saying what is the probability that my weekly return, weekly percentage change is less than -1%. Okay, for instance, once I can open up this thing. So here in this figure, you can see the weekly returns. Now you're seeing this beyond 0, there's -1, -2, -5. As I said, majority of the time, everything is between -5 and +5. So my question is, what percentage of data is less than -5%? In other words, I'm looking on the left side of 0. That too beyond -1. So let's see. Let me select it and let me run it. So 20%. 20%. Okay, last 1 year. Yeah. Hold on. This is not, I think, this is not total. This is S. Just give me one second. Okay, yeah, this is it. This is some other data I'm doing. Yes, okay. Weekly returns, right. So this was weekly. So how many times, what percentage of data for the last 1 year? By the way, this is just 1 year. Okay, this is just 1 year. Because I have like 250 weeks. So I took like 50 weeks. 50 weeks is approximately 1 week. So amount of data that is less than 1 year, or less than -1, 20%. Less than -2, 0.8%. Less than -2.56, 0.06%. Less than -3, 0.6%. Once again, yeah, nice. -3.56, 0.4. -4, 2%. Let's make it -5, because we saw in this figure, we can see very few bars which are beyond -5. So percentage wise, let's compute it. -5, how many data values are less than -5? Once again, 0.02. This means 2%. That means 98% of the data value for this particular distribution is to the right of your -5. only 2% of the values are to the left of -5 and 98% of the values are to the right of your -5. In fact, more than -5. Pretty interesting way to look at stuff. And pretty neat application, by the way, direct real world application. And I can promise you, I can tell you that people do this. A lot of people in a lot of firms, they look at what I just discussed here. Of course, they take decisions based on that, and not on just on the basis of this, they also look at some other things. But to the very core, this is what big firms do at at their big offices, especially in this sector. And of course, these days you have algo traders and so many other things. They do a lot of stuff, but people with real money, they look at statistics and then they take their decision. So this another way of interpreting this result is there is only a 2% chance that on a weekly basis my Nifty will fall beyond 5%. In fact, there's only a 2% chance that my Nifty will fall below 5%. But it has fallen. You can see there are bars here. It has fallen. It fell a lot during Corona times. And of course, when some important and interesting event happens. And of course, you guys can understand, Corona was not a usual event. It was not normal behavior for all of us. It was like an exceptional behavior. Then, of course, we were also using this statistic that I just computed, that 2%. We will also design our own, anomaly detection system or outlier detection system. We will get down to it in just give me 10, maybe 20 minutes. Please let me know if you guys are following or not, or if there is anything, please you can ask it. You can stop me in the middle. You can ask your doubt, or you can shoot anything. Don't think there is anything. I mean, it's not worth it. Please ask whatever you want to ask. So this was a case study based on the Nifty 50 index, or in some cases I also mixed like Bank Nifty, but you can understand this is the core idea of the stock market. Now, let's look at one more case study. Once again, where we do analysis based on distributions. And this is something which is a part of error analysis, which is something that you will see in a lot of my research papers. In fact, my student also does the same thing, residual analysis. And in fact, statisticians also, they do the residual analysis. And we'll look at it. Okay, let's look at it. To look at it, let me go to my this thing, MATLAB. Anyways, okay, so what I'm doing here is, let me show you the data values. Capital M. Okay. So I'm assuming that you guys understand regression. If not, then doesn't matter. In regression, you're trying to predict something based on some input values. Okay. Now this is my data. This is my data. Once again, this data is for stock market because I love the stock market. So this is from the stock markets. The problem here is on the basis of the first 6 rows, on the basis of the first 6, let's say columns, when goes bullet was my fault. First 6 columns, you are trying to predict the value in the 7th column. And this is actually a research paper of ours. So this work is half published. It's half published. It's not completely published. It's half published. Okay. So on the basis of, let's say, these 6 columns, you are trying to predict the 7th column, which I'm sure you guys have seen when you do regression. So regression, if you're trying to predict, so for instance, you do it like using linear models. You can obviously use linear models, linear regression, for instance. You're trying to fit a straight line. On the other hand, look at this index thing, the way this index moves on a weekly basis or whatever basis. I know it's not linear. So linear model is kind of expected to behave poorly. There are, of course, non-linear models that behave very nicely. In fact, that would behave very nicely here in this section. So I have, in fact, we have written a lot of those non-linear models. These non-linear models, they come from the field of kernel adaptive filtering. And then we computed some results. Now let me get down to it. Let me first of all stop sharing the whole screen and let me share the slides only, because I know they will be lag. Just one sec. I am sharing my screen only and we'll share. Okay, done. Now let me get down to it. Okay. We were doing prediction. Okay, we were doing prediction. In prediction, you have your predicted values and your actual values. For instance, you recall the seventh column I showed you, those were the actual values that we were trying to predict. So let's say you get some X, your machine learning algorithm or whatever algorithm you have designed gave you a number X, let's say. Since we are in the world of uncertainty, this X will not be like actual. Actual will be something like X dash. It will be X dash. It will be different. Logically speaking, X minus X dash would be your error value. It would be your error value. And in the data that I showed you, it had like 450 rows. So if you do that, you will get 450 error values. Please, I'm just trying to present the picture in a mental way. Please let me know if there is a problem or if you're not getting that mental picture. So you have 450 error values for any model, not saying linear, non-linear, forget about it. Any model, error values. And for after that, what I have done is, once you have the error values, after the error values, you once again check the distribution of error values. You check out the distribution of error values. Okay, this is the line of thought here. Okay, this is the train of thought coming at your way. Now let me remove the ink here. Now what I have done here is this. I trained the model using non-linear methods. In fact, I trained the algo using non-linear methods, got some error, plotted the distribution of those errors, and this is that distribution. This is the distribution of my errors. Second, once again, I had the same data, so I selected a linear model, ran the linear model, got some error values, plotted the distribution of error values. This is my distribution of error values using linear models. So this is something that you have to understand mentally. This is the distribution of errors. Now, let's get down to business. Once again, we can see the behavior of the distributions in both cases, kind of like normal distribution. That's why I said there is no field in the world that is not touched by normal distribution. Once again, kind of behaving like normal distribution. With, look at these bars. Outliers. They are my outliers. They are not a part of the majority body. They're like lone wolves hunting on their own and destroying the performance of my model. Now, once you have the data, once you have plotted the distribution, very easily using very simple things. What I've done is I just computed the mean of all these error values for both the models and the variance of the error values for both the models. Now, once I do that, the mean of all the error values for a non-linear model came out to be this number. This, by the way, MATLAB wala number, so it's not 6.9 in 10 to the power 4. This is like 0.00069,047. Okay, so this is the way MATLAB prints your error or any number which is very less than one. Decimal board, kind of very close to zero. Look at the mean value, very close to zero for the non-linear one. When I run the linear model, the mean of all the errors what is this? It's 0.0056. Now, look at the variance, which is a very important point. I'm getting the important point. Variance, look at the variance values. 0.01, here it's 0.021. And by the way, are these small values I'm getting? Not because my prediction is very good, no. Because my data was normalized between 0 and 1. So I was expecting to get very less values. It's not that my models are, the models we propose are very excellent. No, it's not the case. They're like the very normal models. That the error values were getting less because everything was normalized between 0. That's right. The important point of note here from our point of view is the variance. Variance in the first case, the non-linear case is very less, 0.01, and here it's 0.021. In other words, if we look at it from an analytical point of view, here in the second case, the error is, by the way, jumping all over the place. The error is jumping all over the place. You can see, in fact, from the labels, what do you want to call it, the x-axis numbers, it's minus 0.5 to plus 0.5, and here it's I can think 0.03 to 0.04. So the variation here in the first case is less, whereas in the second case, the error values are jumping all over the place. It's a situation like this. You asked your model, let's say the actual value was 10. You asked your model to make a prediction, and your model kind of gave like 18, way off margin. The model predicted value came out to be 18, way off margin. We know we will never get 10. The goal is always to get close values to 10, that is 12. If we take an error value, here it comes out to be minus 2, and here it's coming out to be 8. So many variation. Whenever we are building any machine learning model, any predictive model, what we want from residual analysis or error analysis point of view is the variance of errors to be very less. In many situations, in 90% of the cases, if you check out the distribution of your errors, if you are doing regression or if you are predicting something, you will find a distribution that resembles a normal distribution. Yes, 90% of the time, in fact, 95% of the time, you'll find a distribution resembling normal distribution. The goal always here is to minimize the variance in my error values. Some of you will ask why do you want to minimize variance? Common sense. Let's look at common sense. So let me remove this in common sense. How? Let's say predicted value is 18, sorry, the actual values is 18, 18, 19, and let's say 20. Let's say we have some data with these many values. And let's say I built a model, a hypothetical model, which is kind of giving me the same number, which I will never get, by the way, in real world. But for the time being, let's assume we are getting something like this. And now let's compute once again the error value. So error value is always 0, 0, 0. So I'll get 5 zeros. I get 5 zeros. Now this is my error values. This is my vector for errors. After that, let me check the distribution of my error values. If I do that, I will get a bar centered at 0. And nothing else. There will be no bar here or there, none to the left side or to the right side. There will be no bar. This is the ideal situation. This is the ideal situation. Even if it was not 0, even if it was like 1, 1, 1, 1, 1, even then it would have been ideal situation. When Harek was prediction, I would have done this. I would have subtracted -1 in every predicted value, and I would have gotten error at 0. But this doesn't happen. Moreover, in this case, when all the values are the same, the variance is 0. This is the ideal case, which doesn't happen. Now I'm sure you guys must have understood why we should minimize variance whenever we are doing predictive analysis, whenever we are predictive, whenever we are doing predictive modeling. You want a model whose error or which gives you during residual analysis variance on my errors very close to zero. In fact, it should be minimum. And this year, the ideas that I discussed, we also use these ideas in our real work. In fact, you can see my papers on stock market, which by the way, they're half printed in 3 months they'll be done. So you'll see this, we have expanded upon the residual analysis, the error analysis. Furthermore, this can also give you one of the ways, using the ideas of distributions, this can also give you one of the ways to select different models. For instance, in machine learning, first of all, let me look at the time. Yeah, we have 30 minutes. So on the basis of, for instance, in machine learning, you have, let's say, SVM, you have neural networks, you have random forests, and I don't know, deep learning models these days, so powerful deep learning models, XYZ model, so many thousands and thousands of models. Sometimes you are asked this question, which model is the best? Sometimes you are asked this question, which model is the best? What do? You get down to a big computer chalana. Everything you sit down, you get down to business, sat in front of a computer, ran your programs, did everything. MSc you computed, MAE you computed, and so many other things you computed. And let's say some of the models, let's say 3 of the models are giving you similar results. Now the question is, you want to get down to one model, you have to select one model. So in that case, once again, the residual analysis could help. I would recommend go with the one that is giving you a lower value of variance while doing residual analysis. Once again, first check the distribution. There should be very little outliers. For instance, in the linear case, you can see there are 2 outliers here, and here also I can see outliers here. I know this is like coronavirus one outlier. I know there's nothing we can do. But go with the one that is giving you during residual analysis fewer outliers and the variance value of the errors is less. It can also help in model selection. You can Google model selection problem. You will find a lot of literature on model selection. So distributions, once again, they come very handy here. And you can see I am not even using any fancy way of visualizing. I'm just using histograms. And based on those histograms, I'm doing a few things. Any doubt, any question? Anyone?
Sir, as you were saying that we can use multiple softwares for making histogram. So can you suggest which software is best for making histogram?
You can make histograms in a Python, MATLAB, or as I've showed, software as I've shown. Yeah, if you're going with Python, go with matplotlib library. In 2 lines, you'll be able to plot histograms. I don't know about C++ because I don't use C++ because it's kind of detailed.
Okay, sir. Thank you.
So anyone, any other question?
Any other query from the participants?
Okay. So once again, let me check the time. So I have like approximately, I know I have to leave like by 1:50 or something. So 20 minutes. So I will be moving on to anomaly detection and how we can design our own system that can help here. Okay, so let's get down to business once again. So anomaly detection, the last topic for today. I know you guys must be tired of hearing my voice. My students, sometimes I look at when I used to look at their faces, but kya bole? Coronavirus has shifted everything down to online mode. When I used to look at my students' faces and when I was discussing some things which were kind of mathematical and boring, I used to see their faces. Most of them were like half asleep, especially during lunch time. And I used to say a lot of things. I mean, we used to joke so that everybody is kind of attentive. And right now, I cannot see anyone, so I cannot make a joke. Even if I make a joke, someone might say, okay, abhi abhi to mile ho. Why are you doing this? But I can understand it's lunchtime, and of course, you're tired of hearing my voice. So, last topic for today. And it could be very helpful for people who want to use simplicity and common sense to design complex systems. There is this movie of Al Pacino where he says, explain the idea to me like a 5-year-old, like you're explaining it to a 5-year-old. That's my philosophy. If you can explain complex idea in very simple terms, then I think the idea is kind of powerful. Simplest explanation, I think, is the best explanation. There's a Latin word for it. I kind of forgot. I was trying to remember the Latin for it. The simplest, Occam's razor. Now, it is not Latin. Occam's razor. The simplest explanation is, I think, possibly the best explanation. So for anomaly detection, once again, we will not be getting down to complex things. There are so many complex things that people do and people say, no, I am not getting down to it. No. We will be using, once again, the ideas that I've discussed, once again, distributions, and the famous tool, histograms. Once again, histograms, we will use histograms. We will try to identify anomalies. For that, once again, I will take you back to my area, my favorite topic for analysis. Once again, I spent days and days at analysis, analyzing Nifty, analyzing Bank Nifty, analyzing Reliance, HDFC, and so many other stocks. Furthermore, we will be using the idea of normal distribution. Once again, the statistical properties of normal distribution. Kaise? How we can do? Okay. Getting back to the figure I showed you, if you recall, the percentage change. Recall, I showed you the histogram of percentage change. So I already took a screenshot and I pasted it in my PPTs. So this was the histogram of the percentage change in Nifty on a daily basis. This is, by the way, daily basis, not weekly. And I told you, in fact, I showed you, I took data from 30th of November 2016. Yeah. And if you recall, if you remember, during March, yeah, it was Friday the 13th. I remember, yes, it was Friday the 13th of March when Nifty kind of fell down by 10% because I lost a lot of money that day. So you remember, and then you start to blame others. Why bad things only happened to me? Who was to blame? So I blamed Friday the 13th. Let me double check it was the date was right because I know I got hurt very badly. So Friday the 13th of March 2020. Yeah, still right. Friday the 13th, 2020. I was kind of lost a lot of money. Kya kare? Because markets were bad, coronavirus was that first wave tha, peak tha, and so many other things were happening. I invested and then I kind of lost it. But after 2 months, recovered it because market U-turn like yeah. Alrighty. So that day the market kind of fell down. In fact, the main index of India fell down by 10%. I think this is that figure. Maybe 10%. 5 years. Okay, last 5 years. Furthermore, there is something here. I don't know what is this. Maybe it was around, it's 12% or 13, it's beyond 15%, maybe 18%, 20%, I don't know. So looking at this figure, and let's for the time being assume that this distribution is a normal distribution. So generally, what we all do is we take a look at the midpoints, take the midpoints of all these bars. All these bars, we take the midpoint, and then we try to connect all these midpoints with the best fitting line. Okay, with the best fitting line. So I'm trying my best. My hand is not good at drawing. Okay, I'm not an artist. Tabhi to hum is field mein hai. Vana to I would have been a millionaire selling paintings to rich people. Please try to. I'm trying my best to draw the best possible red line. So this is once again looking like a distribution. And I have connected the midpoint, tried to connect. I won't say I've connected. I've tried to connect all the midpoints best and tried to fit the best possible line. Now, this is my distribution. Let's say this red colored line is my distribution. You can see this distribution is having so much of a length on the right side. For instance, this side, left side, this is my left side. You can see I have this line. Furthermore, on the right side also you can see I have this lengthy line. And such kind of distributions are called as the one having, these lengthy lines at either end or whatever end. It could be on one end. They're called as fat-tailed distributions. They have fat tails. And now I think you guys can understand what is the meaning of fat tails. Fat tail means there are some data values which are at the extreme end. Fat tails, these are fat tails. And now whenever you hear the word fat tails, get straight away understand, okay, fat tail means there are some exceptions. Furthermore, you can clearly see these are like exceptions. Market doesn't fall by 10% on a daily basis. There must have been something very, very wrong happening with the world. And we all know what happened with the world back in March 2020. So these are like my exceptions. There are so many exceptions. Exceptions, I think the synonym for exceptions is kind of anomalies. Like anomalies out of the extraordinary. That's why the name exceptions. Again, synonyms. So first of all, if you are working with a normal distribution, it's kind of easy. I'll show you how. Even if you're not working with normal distribution, even then we can engineer a set of rules that can help you identify anomalies. Now, let me remove this ink from the slide. Anomalies, look at the height of these bars. First of all, look at the height of these bars. The exception bars, where Nifty kind of fell more than 10% or approximately around 10%. Bar means, the height of bar means frequency. Very less, in fact, 1 or 2. 1 or 2. 1 or 2, if we compute what is the probability that Nifty will fall below 10%, it will be 1. The frequency of, the number which will be less than 10 in this case it will be 2. By the total size, it will be like 1100 something. You can see the probability comes out to be 0.001 something. Very little chance of happening. Very less chance of happening. Very, very less chance. Now what we can do is to identify such things and to prevent our model from falling into the trap of anomalies, what we can do is, and assuming if the data follows normal distribution, what we can use is, we can go back to this slide. In fact, I'm going back to this slide. We can use the statistical properties of my normal distribution to come up with a set of rules. For instance, once again, assuming on the x-axis here, I have some numbers, like in the distribution that I showed you, on the x-axis, we had like daily percentage change for Nifty. Here, assuming on the x-axis, we have some numbers. In this figure, I'm looking at the third statistical property. There is, in fact, 99.7% of all my data will be in this range, will be between this line and this line. That means here. What we can say is anything beyond this range, anything beyond this range is, let's say some number is here at this end, or some number could be here at this end. Anything beyond this range could be an exception. I'm not claiming it's an exception. It could be an exception. Why? Why it could be an exception? Once again, let's follow same idea. So this is a PDF. The number that is at the center, which are the numbers which are close to mean position, they have the highest probability of occurring. That means a number which is near mu, they have the highest chance of coming up. As soon as you start going away from the mean position to the extreme right or to the extreme left, the probabilities of the numbers coming up slowly becomes less. For instance, a number could be here at this end, let's say this cross and this cross. Very little chance that it's coming from this distribution, although there is a chance, because if it's a part of this distribution, there is a very little chance it will come up. In other words, let's say you have some numbers on the x-axis here, and let's say all those numbers, they follow the normal distribution. And we are trying to randomly pick numbers from this particular normal distribution. The numbers which are close to the mean value, the mu value, will be picked more often. Whereas the number which are at the extreme ends, there is a chance of getting picked up. So what we can do is we can follow this statistical rule of normal distribution. Anything which is beyond, let's say, -3 sigma or +3 sigma could be an exception. Or you want to make it more precise, your system. Let's make it -4 sigma. Let's make it -4 sigma. I don't remember the number for -4 sigma, but let's call it like this. Let me choose a different color. I think I'm just a minute, I'm not getting it. I'm not getting my point. Yeah, it's got it. So let me choose this green color. Let's say anything beyond this green bar that I'm drawing now. Anything beyond the green bar on either ends, the chances of getting picked up or chances of being a part of this distribution is less. They could very well be classified, or they could very well be called as outliers. Some systems in practice, yes, some systems in practice, they follow this rule. Please note this point. Yes, some systems in practice, especially the ones they implement in servers or in real-time systems, they follow this rule. How? Let me tell you how we can use this. Why do they use it? Let's look at this figure. Okay. Assuming, let's for the timing assume that this is a normal distribution. Okay, let's assume for the timing this is a normal distribution. And let's for the timing assume this is my 4 sigma. 10 is my, this is my +4 sigma, and this is my -4 sigma, and this is my mean value mu. Practical systems implement yes this idea. Why? Simply, if number, whatever new number, let's say, comes in greater than 10, print exception. Else, if number less than -10, print exception. So, or print exception, do something. You can say do something. I should not write print exception. Do something, because exceptions you have to handle. Do something. Similarly, do something. My God, this is an outlier detection system that is like coded in 4 lines. 4 simple lines. Really, an outlier detection system can be so simple? I mean, it's in front of your eyes. Where are we wrong? If we are dealing with a data that looks like a normal distribution, and if, let's say, for the time being, we are using statistical properties of normal distribution, plus 4, anything beyond plus 4 sigma, anything beyond minus 4 sigma, we are calling it as an exception. If we get down to coding, then I think this is the main piece of code. 4 lines, nothing else. So we have kind of coded everything down in 4 lines. We have our simplest of the simplest, in fact, simplest yet powerful, by the way. It is a simple yet powerful outlier detection system in for one-dimensional data. This is one-dimensional data. You can obviously extend the whole idea to multiple dimensions, multiple columns. Generally, when you have real-world data sets, you don't have a single column. Of course, some cases, yes, you do. But generally, you don't have a single column. You have multiple columns. So they just extend the idea to multivariate distributions. And if that multivariate distribution closely resembles normal distribution, then done. Our job is done. Very simply, we can code everything down in 4 lines. Of course, if it's a multivariate distribution, then you might have to write a few other things. I'm not getting into multivariate distribution because, again, we don't have the time. So this was something, it's so simple, it's so easy. But the assumption here was the data is following normal distribution. Assumption here is the data is following normal distribution. What if the data is not following normal distribution? That can also be the case. Can also be the case. I mean, we just saw, in fact, I showed this figure. Once again, I have to take, once again, I have to share my whole screen. So, this figure, for instance, this figure that we saw for the data set that I use in my work. This is not normal distribution. And of course, the data here is not huge. We have only 450 rows at this point. But still, you're getting the idea. What if a distribution of data or whatever distribution looks like this? Then what should we do? Now once again our car is like stuck in a pothole. We have got to lift it. How can we lift it? How to get new ideas? How can we do it? We do it, now we are stuck. No, we are not stuck. Once again, we will use common sense. As I always, I've been saying in the beginning, since the beginning of this lecture, when everything fails, common sense will never fail. So well, let's use common sense. So for common sense, what we can do is something like this. Let's say, what if the distribution is not normal? Once again, that was the problem. If it's not normal, once again, what we will do is we will use the ideas that we learned using, that those statistical properties, wala ideas, normal distribution ideas, statistical properties. We will use the same ideas and we will apply it to any distribution. For instance, okay. For instance, once again, let's go back to the screen. And okay, let me clear the. Just yeah, I can have just 5 more minutes, 10 more minutes, 5 more minutes. So let's focus on this distribution. First of all, few rules, few things what we can do is, first of all, if let's find out the range or find out whatever we will find out. Let's say a new data point comes in, let's say X comes in, and let's say X is a part of X is, let's say here, somewhere around here. So you have the data values here. First of all, check, okay, if what is the probability that X could be a part of this. If the probability is, let's say, less than it's very small number, then ignore it. For that, what we can do is, once again, we can use a tool like this, kernel density estimation. Then we can use a tool like this. I said a number, let's say x is here. The x comes out here, around 4. You can see this is a curve. Okay, this is, by the way, a PDF. This is a curve. First of all, find out the height. Find out the height. For instance, at 3.5, the height is this. At 4, there will be some height. Okay, at 4, there will be some height. What you can do is you can specifically design certain filters that if the height of the newest number coming in is less than some predefined value, if the height is less than some predefined value, called as an exception. Or if the height is less than something, it's okay within acceptable range, then say, okay, it could be an outlier, it could not be an outlier. That is something you can do. That is the first idea. That is the first idea. First of all, once again, let me go over it again. Any new number that comes in, I'm pressing control. Any number, let's say there is a new number that comes in. Let's say the number is here at this point, around 3.7 or something. Compute, first of all, compute the kernel density, this curve, this PDF curve, then compute the height. Then compute the height. If the height is less than some predefined threshold value, then say the new member or the new number coming in is an outlier. It's not a part of the original curve. It's not a part of the original distribution. It's an anomaly. This is the first idea. Height, based on height. Height of what? Height of my PDF. Second idea. What you can do is, once again, following the statistical properties, in fact, taking inspiration from the statistical properties of normal distribution. Once again, what we can do is, we can find out a region. Let's say we can find out a region which, let's time being assume, this is that region. Let's assume this is that region. Let's find out what percentage of data is in this region. Let's find out what percentage of data is in this region. For instance, the percentage of data that comes out in this region is 99.5% or 99.7% or whatever. This is a very simple thing, very simple case. For finding the area of a region, you need a lower bound and an upper bound, or the lower limit or the upper limit, in very general terms. Okay, in very general terms. The problem is, what should be the lower bound and what should be the upper bound? For instance, I can shift it to this side. For instance, I can start from this side, the one that I'm shading now. I can start at this side and I can end at this side. And anything which is beyond the acceptable range, I'll call it as an outlier. Another way, another region could be this region. For instance, the one that I shaded previously. That could also be one region, the lower bound and the upper bound. And anything beyond these two acceptable, this region is, let's say, an outlier. So naturally, the question becomes, how do we select the lower limit or the upper limit when the data is not following, once again, normal behavior? So that's again your choice. That's a subjective choice. That is something that an analyst or any statistician can do on the basis of some experimentation, some hit and trial, and some things. Something means they can look at the data, they can just run a few tests, they can just verify a couple of things, they can compute probabilities, and based on that, they can give you a close enough estimate, but you won't get the exact estimate, because once again, it itself is a challenge. So when the data is not following, once again, very quickly revising everything, when the data is not following a normal behavior, what you can do is, you can first of all compute the PDF of the data, which you can do using kernel density estimation. Kernel density estimation. Kernel density estimation. You can Google it. If you can estimate the PDF using this kernel density estimation, there were two ideas that I discussed. First of all, compute the height. First of all, compute the height of the newest point coming in that you're trying to classify as an exception or not. And if the height of the newest point under the PDF comes out to be within acceptable range or greater than some predefined value, then it's okay. Otherwise, discard that point. Say that point is an outlier. Second idea that I discussed was find an upper limit and find a lower limit. Furthermore, find out how much amount of data you want to cover. And anything beyond the acceptable limit will be your, once again, your outlier. So once again, using simple if and else rules, you can code it down, but finding the rules in this case will be a little bit tricky. And it will depend upon problem to problem, context to context. Some problems, it could be something, for others, it could be something else completely. So, any question?
Yes, sir. We
Yeah.
have one question. What is particle filter?
Particle filter is actually a scientific model that uses, very simply speaking, you're asking this question that assuming you are unfamiliar with the field of Monte Carlo simulations, imagine that you are trying to find out if you've seen that movie, okay, Minority Report. Yeah, I'm trying to correlate. My references, by the way, they start with movies and end with movies. So there's this movie, Minority Report. So in that movie, they're trying to, the police is trying to find Tom Cruise, and they send out these very small drones, very small drones that have cameras and everything fitted on them, and they're looking for Tom Cruise. And what they do is they throw the drones in the air at random places, and randomly they are searching for Tom Cruise. Particle filters is also based on the same idea. Let's say you are searching for something. Let's say you lost a key in the ground. Randomly, let's say you throw certain particles in the air, and all those particles, they will search for the key, and then based on their best estimate, they will give you some location, and from that particular location, they will start searching again if they have not found the key already. So this is the whole idea of a particle filter. In fact, it's the whole idea of Monte Carlo simulations in its simplest terms. Other things, I think you and I have to discuss things separately.
Okay. Okay, sir. Thank you. One more query we have. Do we have any specific applications where we can use kernel density distribution?
Yes, kernel density, it's estimation. And yes, modern systems, modern outlier systems, they use this kernel density estimation to engineer anomaly detection, they engineer anomaly detection. The disadvantage of kernel, okay, first of all, kernel density estimations is a very powerful mechanism because you saw first of all, it's a kernel density estimation is a part of non-parametric family of distributions. That means there's no underlying assumption on the data. Naturally, it's a very powerful tool. But since there is no assumption, there's also a drawback. Drawback is it's very slow. It's very slow. If you have a huge amount of data, it's very slow. Practical systems, modern systems, yes, they use kernel density estimation, but they train everything in an offline manner. And once they have the set of rules I was talking about, then they deploy everything in the real world. So I hope that answers your question.
Okay. Thank you, sir. Do we have any other query from participants?
Okay, so this was about outlier detection, and you know outliers destroy a lot of things, but sometimes outliers they do matter. Okay, sometimes outliers they do matter. For instance, Einstein was also an outlier. He was not a part of the regular world. Einstein was kind of super smart. In fact, Sheldon Cooper from the Big Bang Theory, he's also super smart.
Yes.
So once again, he got a Nobel Prize. But he's like once again an outlier. But outliers they matter sometimes. Don't just discard them. without even looking the core properties. But yes, that's what generally people do in data science and in statistical fields. They generally tend to throw outliers. Sometimes in social life outliers. Okay, so this was all about distributions, anomaly detections, and the pattern finding. Guys, please keep in touch. So my email ID is here. And if there is any question, anything you want to ask, please do ask it here, or you can always send me an email.
Okay, thank you so much, sir. Any other query from the participants? Okay, sir, we have one more query. Among all the distributions, which distribution is mostly used?
Okay, that depends. See, if it's a scientific field, then people tend to go with, in fact, if you're from electrical background, I had worked with electrical people, they always go with current density estimation. They always go with current density estimation. Even if you, let's say there's something called as a noise thing, a noise element. If you say, okay, I'm assuming the noise to be Gaussian, they will start arguing with you. How can you assume the noise to be Gaussian? What's your idea? And so many other questions. Okay, they'll spend like 30 minutes scratching, and you'll spend 30 minutes scratching your head. Why did I argue with this guy? So, in reality, in the real world, of course, my knowledge of other fields is very limited. Don't know about biostatistics and all those things. But so far, I know mostly people tend to use normal distribution. Yeah, I know it's controversial. Yes, the statement is controversial. But normal distribution is easy to work with. Normal distribution has only one bell-shaped, it has only one bump at highest point. Furthermore, the statistical properties and all other properties have been extensively studied. That's why most occasions people prefer, in fact, even I prefer to go with normal distribution. There are situations where you cannot go with normal distribution and you have to work with other distributions. For instance, Weibull distribution. For mechanical failures, people also model mechanical failures. When will my car break down? Or when will my axle or my bike break down? Which you know is a practical problem for a car making company. So they use like something called as Weibull distribution. It depends on the application.
Thank you, sir. We have one more query from Saranya S. Can you suggest any best outliner detection algorithm?
Outlier detection algorithm, once again, I just discussed a few outlier detection algorithms. See, I focused on distributions. Okay, because the topic was distributions. There are outlier detection systems based on the idea of distances. For instance, okay, I'm focusing on the same slide. Say you have a bunch of data points here in one group. And let's say you have an outlier, a circle, which is not a part of the original group. Clearly, we can see this thing, okay, that this circle is an outlier. I focused on detecting outliers using distributions only, which of course, if you do that, you will get once again a very fat tail because of this circle. Some systems, what they do is they first of all compute, let's say the centroid, and I'm pointing the centroid with this dot. Centroid for let's say a group. And then they will compute the distance of every point from the centroid. You can always compute the distance, the one that I have shown here with arrowed line. And if this distance is more than some, once again, predefined value, that guy is an outlier. So this is also a practical system. And most people also go with this. It's this or this, whatever you want to choose. It's one and the same thing. In fact, MATLAB, for instance, let me show you this thing. For that, I have to stop sharing my screen. And I have to share the other screen. Okay, so I'm sharing my whole screen once again in MATLAB. Okay, this is my MATLAB. Let's say, for instance, M is outlier. So there's this predefined function in MATLAB. Okay, I've not passed in any arguments, so I have to pass in the arguments, I have to pass in the data and so on. Then I will be able to come up. So this is once again a practical thing is outlier. What does this do? This once again computes the absolute distance. This idea. Okay, so this is once again a practical application of outlier detection system. This is based on distance.
Okay, sir. Thank you for such a nice explanation. We have one more query from Dr. Gagan, and his question is, are outliners the part of data?
Yes, outliers are a part of data. Look at this figure. Look at this figure. The figure that I am showing on my screen at this point. I'm sharing my whole screen. Okay. This is, by the way, Nifty returns on a daily basis. You can clearly see there are a few outliers. Outliers, they destroy everything. But I know it won't be right to say this, but when you are in times of outliers, for instance, or when you're in times of exceptions, or whenever you're in exceptional times, then things are different. Things are either good or they are very bad. Very bad, we are living in times of exception. Okay, coronavirus, this is the first time, in fact, in 100 years, that such a pandemic has hit all of humanity. And you all know the situation was really bad. And the situation is, in fact, still bad. Possibility of third wave, the sword of third wave hanging on all of our necks. This is once again outlier, and this outlier is a part of our life now. Same way, this is my data, and outliers are a part of my data. Why people focus on outliers is, I'm sure, let's say we have three x crosses and we have a circle. If I'm asked to fit a line in, let's say, only the crosses, I will be able to do so very simply. But if somebody asks me to include all 4 points and then fit a line, the line would be like this, a straight line. That's why outliers, they tend to destroy certain things. That's why people, they don't want to focus on outlier. They want to remove it. And if we remove it, we will get the original line back, one that was passing through all the three crosses. But outliers, yes, they are a part of your everyday life and in fact your data. I hope that answers your question.
Thank you, sir. Our next query is, any example where outliners are more useful than actual data?
Where outliers are more useful than actual data.
Yeah.
I think the question is not rightly framed. Outliers are useful than data. Don't you think there's a theoretical problem
In
here?
which places outliners are like applications of outliners?
Okay, applications of outliers. Once again, I can give you an application of finance. Whenever you see outliers, the fluctuations in the market, that it tends to increase. Okay. And the whole world of trading, especially institutional trading and so many other things, they are based on the idea of volatility. Volatility basically means fluctuations. Just like life, no, life tends to be sometimes monotonic. सीधा सीधा चल रहा है, go, wake up, have breakfast, go to office, come back, and so on. Bring some different thing in your life, and you see things get interesting. Either they get good or they get bad. Same thing. People in finance, they love volatility. Volatility is when things are interesting. And by definition, when there is volatility, there is too much fluctuation, things tend to get out of the normalish behavior. Things tend to get close to abnormal behavior. So this is actually a practical example of, once again, outliers and abnormal behavior that is interesting to people and models. People have big firms, they have models and models on the base built on volatility. For instance, once again, if you can, if you have seen that movie, I forgot the name. I forgot the name. Okay, and again, it's a stock market based movie. Once again, it's a financial sector based movie. It was based on 2007, the financial crisis. So that is where things get interesting. Sunita, thanks. Okay, I can also see.
Okay, thank you, sir.
Yeah, I think how to get rid of it. Pranati, Rakshit, I was discussing the same thing. How to get rid of it? Okay, just press delete. Simplest thing, Pranati. How to remove it? Just press delete. If you identified outlier, just press delete. Or what? I mean, delete is a very common language. I said you can, of course, remove whatever. If it's a row, then remove row. But the core idea is just press delete.
Remove the data.
They remove that data point. I mean, that's what I was saying in a kind of a comic way. Just press delete. So just remove that point. Yeah, Rakshit, let's remove that data. Yes. I was trying to be funny, but it's, yeah, the idea is remove that point.
Any other queries from participants?
No, Ajit, actually that code, I cannot give it to you because that code is for one of, it's written by one of my PhD students, and she's actually publishing a few papers on the same. Sorry, but I can always give you the reference where you can find the code. Yeah, you will get the base code. The reference you can go on GitHub, kernel adaptive filtering toolbox.
Okay, any other query from participants? Okay, I think we don't have any other query now.
So I'll be stopping here. First of
Yeah.
all, yeah. So thank you very much, guys, for listening. Thank you very much, Anushri, for having me here, giving this talk. And I know I kind of bored everyone. For 2 hours, I was like talking.
No, sir, actually session was very interactive. We all have learned a lot.
Thank
Definitely
you very
we are
much. Yeah, okay. So please, if anyone has a problem, anyone has any doubt, I shared my email ID. You can always contact.
we are getting few feedbacks from the participants as well. They are saying that session was very informative and it was very wonderful session. Yeah.
So thank you, Anushri.
Thank you so much, sir, for such a nice session.
Thanks for having me here.
Thank you, sir.
Thank you. Bye, Pranati. Bye, everyone. Take care. Enjoy.
Thank you everyone for attending the session. We will start our next session at 2:30 p.m. So thank you.
Good afternoon, everyone. On behalf of Indira Gandhi Delhi Technical University for Women, I feel privileged to extend my warm welcome to all present here. Today's talk on predictive analysis in healthcare will be presented by Dr. Ashish. Dr. Ashish is currently working as an assistant professor at IIIT Vadodara since 2016. He holds PhD and MTech degrees from DAIICT Gandhinagar in 2016 and 2010 respectively, and a BE in Computer Science and Engineering from Rajasthan University in 2008. His research interests include image processing, pattern recognition, soft computing, and medical image analysis. Over to you, Ashish, sir.
Okay, thank you for the introduction, and I hope we are good to start now.
Yes, sir.
Okay, so good afternoon, everyone, and I hope you have enjoyed your lunch, if given permitted by organizers. But I know last session was delayed, so if we are all okay, we can go ahead, or we can wait for 5 more minutes if you need some break.
Sir, we can go ahead.
Okay. Okay. Another thing, I just changed my title of this talk. It's now Deep Random Forest Architecture for Brain Tumor Segmentation instead of predictive analysis in healthcare. So tumor segmentation is also a challenging problem in healthcare. We'll discuss more on that part, and then I'll discuss more on random forest approach for making a prediction for this problem. Okay, so it's a this talk is more specific now on brain tumor segmentation challenge. Okay, in case if we are not able to discuss during the meeting, or if you want post talk discussion, you can always feel free to send email to me. ID email address is here. Okay, so let's begin and try to understand what is brain tumor segmentation problem is. So in human brain, glymus is one of the well-known tumor form, which is leading cause of death using brain tumor, and that comes up from glial cell in the human brain. Okay, and this glymus tumor is classified as low grade and high grade. So we call it as LGG, low grade glymus, and high grade glymus HGG. So these are the standards given by WHO. Uh, there are few other standards called grade 1, grade 2, grade 3, grade 4, and lower grades are considered in LGG and higher grades are in HGG. Okay, so higher grade is actually more dangerous in terms of its growth in the human brain that causes death. Okay, so segmentation in HG cases is more crucial for finding out the progress of a tumor in the zone or area, and we need a solution for that purpose. Okay, because it's more dangerous and it captures the human area or human brain more quickly. So there is a challenge associated with one of the leading conference in the medical imaging called BCI conference. So this is called as BRATS, Brain Tumor Segmentation Challenge, and this is the every year is hosted by the group of researchers. This is the 10th year of that challenge. So this has been 10 years of continuous uh, progress of this challenge, and the data set and everything has been going ahead directly. So organizers keep on increasing the data set size and more challenges associated with human anatomy. And interestingly, the as a challenge part, tumor region itself is divided into sub-regions. So within a region of tumor, there are other sub-regions which are equally important for medical purposes. Okay, so that's a make a challenge more interesting. Another thing is the problem of tumor segmentation is actually considered as imbalance problem. Imbalance in the sense tumor region in most of the cases will be very small compared to given the image size. Okay, so if you consider a LGG case, where the tumor grade is very low, it will have a very small number of pixels or area in the scan. Okay, so the number of samples available for processing will be very less. And when we talk about the sub-region, that will also becomes automatically very less. Okay, so that makes a problem imbalance. So let me show you what actually it looks like. So the rightmost side, the image D, which you can see is a complete human brain scan, and then the area which is colored is a complete part of the affected area by tumor, okay, or tumorous, or you can say abnormal area or non-normal area, which is not belongs to healthy human brain. Okay, so on the left side, this has been represented as individual components. So first one, which is colored in yellow, the first row left top is called a complete tumor area. Okay, which has all the sub-regions. So if you want to find out tumor area, you have to find out each and everything which is represented as yellow color. Okay, and the bottom row is a image scan from clear image, which is a modality when you get a scan that we discussed yesterday in my talk. So from MRI scan, we get different modalities for the same scene or for the same patient. So from the flare scan, this is represented. The second one is represented as orange color, which is tumor core. Okay, so tumor core is the area which is actually tumorous part. Okay, and other than this orange part which is shaded in yellow is called edema, which is like a swelling of a tissues over there. Okay, so swelling is also dangerous for further analysis because that is suspectable area where tumor can grow. Okay, so these tissues which are represented in orange are tumor area, and then it will grow towards the area where there is a swelling. Okay, so this is called edema area, which is other than red area. Within this tumor core, this has been divided into two parts. One is called uh, enhancing tumor. Enhancing tumor is the area where it is uh, possible that tumor will grow over a period of time. Okay, so that is represented as blue in color, and the green color area is called necrotic area, which is like a dead cells, which are completely dead, and they may not go make a progress over a period of time. But yeah, blue color area is dangerous because it will grow over a period of time and may lead to paralysis attack. Some of the body functions may not work. It may cause a human death. Okay, so this is a major challenge to segment out this complete area. So as a uh, as a segmentation of brain tumor, we have to find out the complete area, which is represented as yellow. That is the outermost area, or we call it as whole tumor, a complete tumor. Then tumor core, which is represented as orange color, which is part of which has a two subpart represented as green and blue. Okay, so these are the areas that we have to find out in one area. So the challenge over here is first to localize where the tumor is. Okay, so it may be like in image D, tumor is in the right portion. It may be possible that in some patients tumor is on the left side. In some patients tumor may be on the bottom part. It may be on the top, or it may be very small. In representation, like in LGG cases, it will be very small. Okay, so this is considered to be a HGG case, high grade tumor, where you can see 30% area is already captured by tumor. Okay. So this is one sample image from 2017 challenge dataset, and it will used since long. So as a challenge part, there are four modalities available. One is called flare, fuel attenuated representation of scan. Second one is T1 image. Third one is T1 contrast cadence image, and the last one is T2 image. So this is just a slice representation of a patient ID is there, TCIA 231. Okay, and it is ground truth is this one, which is representing different sub-regions over here. And you can see the ground truth area. If you talk about the complete tumor or whole tumor, the ground truth has a very small representation. Okay, given the image size, tumor area is quite less. Okay, so your number of samples goes drastically down. Instead of the complete image, it will be very few. Okay. And even then, if you talk about the only blue color area or green color area, number of samples will also goes down again. Okay, so that makes a problem imbalance, and maybe possibility that in some of the patients there is no green color. Okay, so this one, which is a dead cell, there is no green color space available in some of the patients. Maybe possibility that the swelling area, which is edema in medical terms, or a swelling area which is quite less. Okay, so it depends how much space is captured so far or affected so far by tuberous cells. Okay, so that makes a task difficult and a problem as imbalance. Okay, where number of samples for the task to be performed are not equal. If you simply want to select a problem as a classification of a patient is affected by tuberous cell, or a patient has a tumor, brain tumor or no. So if you say yes or no kind of classification or binary classification, so the number of samples available to you in case of saying yes, there is a tumor is very less. Okay, or if you go in terms of pixel wise, that will also become very less compared to healthy pixels or tissues there in the patient. Okay, and then when you go further into the sub regions, this becomes very less. Okay, so that's the idea of a challenge, and then we have to work out to find out all these different sub regions there in the image. Anyone, any queries here so far?
Please raise your hands if you have any queries.
Okay, so yeah, is there any query?
You can also write your queries in the chat box.
Okay, so let me go ahead meanwhile. So the question is, which method is going to give the best result for such problems where human life is involved? So there is no as such the best method available which will work for all the cases around the globe. Okay, so this is still an open area for research where people are working, and you can assume that the organizers are still holding this challenge from last 10 years. Okay, so it started in 2011 and we are having the 10th edition of this challenge in the summer period. So we had challenge in May this year and it is about to finish in October. So first question is how to select a method for any such problem. So there are methods available like deep CNN, deep convolution neural network, random forest, support vector machines, or you can plan something which is out of box. You can propose a new model, new architecture, but that should match with the problem. So your methods philosophy should be in synchronization with the problem what we are working with. Another challenge or problem is it a ill-posed problem like what we discussed yesterday in case of image denoising, that you have one equation and two unknowns. Okay, so is your problem that you are working with is a ill-posed problem? Okay, yes or no, that you can decide. But the today's problem, brain tumor segmentation, is imbalanced problem. It's not an imposed, but it is imbalance. How to get scattered data set? That is another big question for working with medical image analysis problems, because getting a scattered data set is essential to validate or compare the methods which are there in the literature. Okay, otherwise it will be difficult if everybody works on his or her own data set and there is no common standard for comparison. Okay, so for if you are willing to work on brain tumor segmentation problem, this dataset is one of the standard dataset now acceptable in the community, where you can compare your results with all the methods, okay, which are participating in the challenge. So there are sources like for tumor segmentation, for brain tumor segmentation, BRADS is the dataset which is well known. ADNI is another repository which has datasets of is a collection of different problems associated with the tumor or brain, like Alzheimer or Parkinson's and so on. Along with that, the MICAI is the largest medical imaging conference around the globe. So they also host various challenges along with the main conference. Okay, so you can visit MICAI conference page and you can go to the challenge page where you can register yourself, you can access the data and you can participate with the particular challenge where the problem is already specified. Similarly, ISBI, it is International Symposium on Biomedical Imaging. This is another conference acceptable globally, and they also host some of the challenges every year. So you can visit these two conference pages every year, and you can see which problem makes excite you, and you can start working with them. And data sets will be available over there. Okay, there is a query from Aditya. So these are the sources from where you can get the data sets. So for brain tumor, BRADS, for other, this ADNI is having a large collection. Then MICAI challenges or ISBI challenges, the organizers do provide the various data sets to work with. So from this, you even after the challenge is over, in some of the cases, they keep the data set available to the community. If anybody wants to work even after 1 or 2 years down the line, they can register themselves on their portal and then you can get access to the data sets. So these are the major sources where you can get the data sets. Aditya, I hope your doubt is resolved. Now, when working with the problem and when you have a data set, so another question is how to generate features. When you work with machine learning problem, then features are one of the key things that we have to think for, and how to classify an image or a pixel or tissue in the tumorous part or non-tumorous, what else. So features will be the representation with respect to problem. So now CNN is already there, which does everything for us. So the question or that makes life simple, then why to worry? Okay, so CNN based methods, you just give the inputs and you just do the minor changes in the architecture, or if you proposing some new architecture, then you do the complete training from the scratch and CNN will do the job. But major thing over here is that you have to understand how your architecture is behaving. and what are the rationales behind the decisions made by your architecture. Okay, so most of the time people configure 2 layer, 3 layer, 4 layer number of features, and they change the fully connected layer to some other thing, and activation functions, they do some changes. Okay, so but you have to justify how your architecture is adopting the challenge or problem which is there. Second one is handcrafted features. So the conventional methods do require features to be supplied as a part for performing the task. So random forest, support vector machines, and other methods do require features which are hand generated or handcrafted features, where as a researcher you can create your own features which you feel is suitable for a particular task. Okay. So now, since CNN is there, so this there are majority of the community is working with CNN because you don't require a features, or you don't have to be worried for features. Okay, but now in this talk I'll present a couple of my work where we have done with the handcrafted features. Okay, and again with the given set of features, if there are hundred or thousands features, then which set of features are going to helpful for a particular problem or which may not be helpful is again a challenge to find out. Okay, so you have to be cautious that if you generate 1,000 features, then high chances are that some of the features may not be that much informative or they are redundant, so we have to truncate such features. Then how to measure the performance of method. So in case ground truth is available, you can simply do the Gauss coefficient. You just compare how much matching is there. Otherwise, in case of real data sets where ground truth is not available, then you have to devise some mechanism, or you first apply your method on the simulated data sets, and then you work on the real data sets, and then in some cases, if you have a facility available or association with any hospital, then you can take help from doctors to validate your results. That is also possible. The last one is a major issue if you want to work with some of the different problems, like you are looking for helping the community or society, but data is not available. So if data is not available, then we are helpless. So you can create your own database with the help of doctors and hospitals, and publishing such research is also well accepted in the community for making it a global standard data set for a particular problem. That is also well acceptable. Okay, so you need to have a tie-up with the doctors or hospitals to get a particular data set for a particular problem, and then you can make it available for everybody. Okay. Now, so let me start from a very basic thing for random forest, which is called decision tree. Okay, so that's the heart of a random forest, decision tree, and decision tree is working based on the features. Okay, so this is one dataset, a very commonly used dataset for explaining decision tree. Okay, so what this table looks like is we have a 14 days of samples or collections of weather conditions. Okay, and our features are outlook, temperature, humidity, and wind condition. And the question that we are looking to be answered is whether to play tennis outside or not. Okay, so the problem is yes or no type of problem, binary classification. So day one observation is outlook condition is sunny, temperature is hot, humidity is high, wind condition is weak. So the decision is you are not suggested to play tennis. Okay. Similarly, on day three observation, outlook is overcast, temperature is hot, humidity is high, wind condition is weak, but the condition is suitable to play tennis outside. Okay. So the answer is yes in the third observation, but answer is no in the first observation. So these are the 14 days observation. Okay. And now we can learn from this working gauge what is going to happen or what is the suggestion or prediction on day 15 if we get some four values, one for outlook, one for temperature, one for humidity, one for wind. So based on our working gauge results or experience, what can we predict to whether play canis yes or no? Okay, so that we can solve using decision tree, a simple tree which will be taking conditions like if and else cases. Okay, so this is one decision tree which is created using features as a node in the tree, and then the branches are the values which are possible. Okay, so if you look at this table on outlook feature, so outlook has a three possibility. Outlook condition can be sunny, it can be overcast, it can be rainy condition. Okay, so for this outlook node there are three child nodes. One is sunny, one is overcast, one is rain. Okay, and if you look at this overcast, there is if whenever outlook condition is overcast, you will see a decision always as yes. Okay, this one. So over here on day 3, outlook condition is overcast, answer is yes. On day 7, it is overcast, answer is yes. On day 12 and 13, it is overcast, answer is yes. So there are 4 cases. So whenever outlook is overcast, irrespective of any other feature value, answer is you can play. That is yes. Okay. So now, if on day 15, if we observe outlook condition as overcast, we don't require any other feature and we can directly make a prediction that we can play. Okay. But in case if it is sunny condition, then we have to check humidity. Then humidity has two possibilities: either it's a high or it's normal. Okay. So now, based on the samples that we have with outlook condition sunny and outlook and humidity condition high, answer is no. And if humidity is high, then answer is yes. Okay, even if it is outlook as sunny. But if outlook is rain, then we have to check what is the wind condition, and then if it is strong, answer is no, and if it is weak, answer is yes. Okay, even if it is rain, if wind condition is weak, we can play tennis. Okay, so for playing a tennis, there are 3 possibilities that we can observe. That first one is outlook is overcast. You can play outlook is sunny, but humidity is normal. You can play outlook is rainy, but wind condition is weak. You can play, and then in rest of the cases, answer is no. Okay, so this is how decision tree looks like. And once we have day 15, day 16 onwards, we can look at the tree and just go through, just follow the path, and we'll get to know the decision. Okay, so this is the prediction node. The last node, which is called leaf node in the tree, is your prediction values. Okay, but the big question is how to construct such tree. Why we consider outlook as the first, humidity over here, wind condition on the right side, and we have not considered one feature. Okay, take a look. We have not considered temperature so far in our prediction. Okay, and humidity is only on one path, wind condition on another path. Okay, but they are also not repeated. So the big question is how we can construct decision tree. That we will discuss in the coming slides. Anyone, any query over here? Maybe a couple of quick queries I can take up.
Please raise your hands if you have any queries. You can also type your questions in the chat box. So we have one question.
Okay.
Yeah. Sir, Dr. Gagan is asking that why we have selected humidity and wind, why not temperature?
Okay, I'll come to that point in my next slides, in coming slides. So my skill, the question is here, like how to construct decision tree. We will discuss. Okay, so let me go ahead and we can discuss how this construction will take place.
Okay, sir.
So the property of decision tree is it's more like a hypothesis space where we can put boundaries. So it may be your parameters may be discrete or continuous, and we can put the boundaries to classify the space. Decision tree is a supervised learning method where you need a ground truth also. So we in our example there are 14 samples were there which has the answer. Okay, and for day 15 we are making a prediction. So that's an example of supervised learning, and it's a more like a rule based. From decision tree we can derive the rules. Okay, so like for playing a tennis as yes, we have a 3 possibilities. Similarly, not playing tennis, we have 2 possibilities from the decision tree. So it's more like just hooking and or conditions. Okay, so a very small example is there on this slide at the bottom. So I have a feature x1 and x2 and values as 0, 1. Okay, simple boolean values you can say. And we are classifying space, this 2D space as class 1 on the diagonal side and class 0 in another diagonal side. Okay, so for example, if I have x1 value as less than 0.5 and x2 value less than 0.5, okay, so we are going to classify this as a class 0 over here. But if x2 value is more than 0.5, we are going to have class 1 over here. And if x1 is more than 0.5, then we check again x2 values and again we classify as 1 and 0. Okay, now if this is my classifier, then what we can do is we can always make a rule where by following the path from the root node. Okay, so for class 1 what we can do is we have a rule like this one. If x1 is less than 0.5 and x2 is greater than 0.5, will be a class 1 label. Okay, so I'm just writing in a short, if x1 is less than 0.5 and condition, logical and, okay, and x2 is greater than equals to 0.5, okay, this path is going to give us a class 1. Or, okay, so this is logical or, and if x1 is greater than or equals to 0.5 and, okay, so we are following one path will be connected by all the AND conditions and another path will be by OR. Okay, so now x1 is greater than 0.5 and x2 value is less than 0.5. Okay, so these are the two paths possible for classifying class 1. So we can derive this rule. Okay, so first clause is connected with AND, or one path is connected with AND, another path is connected by OR. Okay, so simple AND or OR logic. So that way we can form a rules over here. Okay, so you don't require to store a complete tree in the memory. If there are memory constraints, you can simply derive a rules and then you just save it. Okay, so this is more like a rule based system. Similarly, we can derive a rule over here. So if outlook overcast, and so this is one path for playing tennis. If outlook is overcast, yes, then, or outlook is sunny and humidity is normal, answer is yes, or outlook is rainy and wind condition is weak, answer is yes. Okay, so there are 3 paths you can represent as a rule. Okay, now this is another example from UCI repository for working with tabular kind of data sets for machine learning tasks. So this is a data set called MPG, for miles per gallon or average value for a particular car. Okay, and the features to define MPG value. So MPG values are considered as whether a car having a good mileage or bad mileage. Okay, and features considered as number of cylinders car has, its a displacement value, horsepower, weight, acceleration, model year, in which year it is designed, and the maker. Okay, so different values are there. It's a 40 records small data set with 7 features and one output value. So this is a supervised learning based example. Now you can see number of cylinders which are either 4, 6, 8. Displacement is either low, high, medium. Horsepower either low, high, medium. Weight low, medium, high. Acceleration again low, medium, high. But model year is in the time zone. Okay, so 75 to 78 and so on. And maker is either Asia, America, Europe. Okay, so this is how features look like. A few are discrete, one is in time range, like that. Okay. Now we call this as a scum. Scum means we just partitioning the data. So at initially we have a 40 records. Okay, and out of those 40 records, there are 22 which are bad examples. Bad examples in the sense that MPG values are bad or average is bad. There are 18 examples where average is good. Okay, so we can start for construction of tree. We start with a root node where we have a 40 samples. Okay, now we can take one feature like a cylinder. So number of cylinders 3, 4, 5, 6, 8, so on. And what we can see that how based on the cylinder values, what is the breakup. So for if number of cylinders are 3, there is no samples available to us. Number of cylinder 4, there are 4 examples which are bad MPG values. There are 17 examples with good MPG value. Similarly, for 5 cylinders, there is one bad example. For 6, there are 8 bad examples. For 8, there are 9 bad, 1 good. Okay, so what we can do is by looking at this classification, we can predict except one. Like when number of cylinders are 4, we have 21 examples. Okay, and out of that, around 80% is good examples. Okay, so by looking at a car which is manufactured and having a number of cylinders 4, we can predict 80% times or probability as 0.8 that it is going to have a good mileage. Okay, but if you have a number of cylinders 6, all samples that we have seen are bad examples, so we can say it is going to be a having a bad mileage. Okay, so this is how we can make a prediction. Okay, but now question is again how to grow a tree. So for that, okay, so this is just a final picture that tree is going to look like this, but there is a logic behind the construction of this tree. Okay, and every node which is we can call as a leaf node is a predictive node where we can make a prediction based on the number of samples available to our side. Okay, so you can see every node which is leaf node, there is a decision written over there: predict bad, predict good, and so on. Okay, so there is a possibility that we may not include all the features in our calculation or a construction of a tree. A feature may appear in multiple branches, that one feature appearing higher than the lower in the other path. Okay, so like this one, you can see let me see horsepower. So horsepower is appearing over here. Okay, that you follow from the root node with number of cylinders 8, and there we see a horsepower. However, on another path, when you start with root node, number of cylinders are 4, maker is Asia, and then we look for the horsepower as a feature. Okay, so horsepower is appearing at 2 places at the different levels. Similarly, you can see acceleration is appearing at 2 different levels. But when you go with the cylinder 4 with maker Asia, horsepower medium, then acceleration, we are not talking about the model year. Okay, so some feature may appear, some may not appear. That is also possible. On one path, no feature may appear more than once. Okay, but at in case if you are dealing with continuous feature, you may have a different threshold or cut values over there. Okay, so for continuous, there will be a range that you can define over there. And there is a possibility that there may be multiple possibilities of having a different trees for learning the same concept, for learning the same problem. Okay, so we have seen one tree which is possible. There may be another tree possible for the same problem. Okay, and the trees, if there are multiple possibilities, then they may not have a same size. Okay, that may also be two different things. Okay, so this is one example which is written over here, that we are learning a concept like A and B or not of A and C. Okay, so then there may be two possibilities that we can have over here. So in computational complexity wise or algorithm wise, learning a decision tree is hard. Okay, so those who are from computer science, learning a simplest or smallest decision tree is NP complete problem. Okay, so we can, if it is NP complete, we can always make a heuristic approach to solve the problem. There is no straightforward path to solve the problem. Okay, so we goes to a greedy approach to design a tree for our problem. So we start with the empty decision tree where we have all the samples over there. Okay, like a root node which has 40 samples over there, and then we gradually break down the sample space based on the best attribute available for classification. Okay, so we are looking for a best attribute which will give us a better classification than the root node. Okay, and then you iteratively doing this path uh, every time, and then you keep on cut down the data into small parts. Okay, till the time you are not able to have a decision properly or clear cut decision between a good example or bad example. So the initial proposal was called as ID3 algorithm, and later on it was improvised, called as a C4.5 for ID3 plus improvement, so C4.5 algorithm or C4.5 decision tree. Okay, so but idea is heuristic, that you start with empty decision tree, find the best match or best attribute available at that particular node, you split the data and keep on doing this task till the time you don't have the samples belongs to one class. Okay, if there are samples belonging to multiple classes, you cannot make a decision. Okay, so let me just go back quickly. So look at this tree over here. When you follow the path, in case over here there are two samples, one belongs to class bad, one belongs to class good, so we have equal number of samples in both the classes, so we can't make a decision. So it's unexpectable. We cannot be break down this node. So either you can predict bad or you can predict good. Okay, so there is no rule available. But most of the cases, even if you have only one example, so you can make a decision easily. Okay, so here in this one, there is one sample which is good example. Similarly, over here on this node, there is a 9 samples which are of bad, but there are no good examples. Okay, so we can make a prediction as bad. If there are samples available from different classes, we have to do the iteration every time. Okay, now, so we started from root node where all the samples are available. Now assume that assume that cylinder is the best attribute. I can give a classification. So we are going with the best attribute as cylinder, and we are splitting based on the features. Okay, so our 40 samples got split over here, like 21 with the number of cylinder 4, 1 is with 5, 8 with cylinder 6, and 10 as cylinder 8. Okay, so we got all the 40 divided into different nodes. Okay, now when you have a number of cylinder 4, the best attribute we can have is maker. Okay, how to select best attribute I'll discuss after some time, but assume maker is the best available with us or best attribute we have. At the same time, when you have a cylinder with values 8, the best attribute is not the maker, it's a horsepower. Okay, so For given these 10 samples now, instead of 40 samples, now we are looking for the 10 samples. So which is the best attribute possible to classify these 10 samples? We should select the attribute according. Okay. Similarly, for this 21, when your selectors are 4, you can select the best possibility. Okay. Now the question left is how to select the best one. Okay, we know the process, but how to select the best one at every point of time. Okay, so this is what we discussed. So we just keep on partitioning the data. So this is original data set shaded in gray, and then we keep on dividing the data sets. So from a bigger problem, we are just cutting down a problem in a small chunk. Okay. So here is the tool available for us to measure the uncertainty. Okay, so how to classify? So we are using a information theory concept called entropy. Okay, so entropy will give us an idea about the randomness in the samples. Okay, randomness available. So this is the formula that we have seen since long, like entropy over here. Okay, so this is how the graph of entropy looks like. If your samples are equally divided in terms of machine learning, you have a 50% in both the classes, you have the high entropy. Okay, if your number of samples belongs to only one class, either of the class, then entropy will be 0. It means there is no randomness. Okay, so we are going to use the notion of entropy to find out the best attribute. Okay, so using entropy, we
So,
can define, yeah, sorry.
so we have one question from our participant. So Dr. Gagan is asking that how the partitioning of data set is done.
Yeah, this is what I'm explaining.
Okay, sir. Okay.
Okay, so using entropy, we define another term called information gain. Okay, so entropy is representing the randomness in the system or in the samples, and if we lower down the randomness, we are gaining some information. Okay, so using the information gain, so okay, let me just draw this one. Graph again, which is entropy graph. So over here it is 1, it is 0, and entropy is maximum over here at 0.5. So if I have a 100 samples and 50 samples belong to class 1, another 50 belong to class 2, I have a high entropy. Okay, randomness is high. If I have 70 in either of one and remaining 13 another one, I'm just lowering down my entropy. And if I have all 100 belongs to one of the class, okay, there is no entropy. Like I don't have to look for any classification algorithm to classify my other samples. Okay, because what all samples available to us belongs to the same class. Okay, so that idea we are going to use. So that we call as information gain. Okay, so gain in information gain will be reverse in the entropy. So decrease the uncertainty or decrease the randomness, and you will gain more. Okay, so what we have to calculate is the entropy of y before any split. So at any point you find out what is the entropy. Okay, and then you select the feature and then check what is going to happen. Okay, so entropy after split. So at any node, if I'm there, okay, now I have to split my data. So now what is the entropy in the system at this node over here, and what will happen if we observe the feature x. Okay, so I may have features available to me as x1, x2, x5. For example, I have 5 features and I have to select the best feature among them. That will give more information gain if I split by x1, x2 or either of the feature, or less in entropy. Okay, so what I can do is we are representing h of yx. Okay, your y is node and given that feature x. If I observe feature x, what is going to be my entropy? Okay, conditional entropy. Okay, so what we can do is we can do h of y given x1, h of y given x2 up to h of y given x5. Okay. Now the gain will be difference between the two quantities. Okay. So here is this one, the formula. So now we have to maximize the gain. Okay. So argmax representing the maximize the gain based on the feature I. Okay. And what is that is on the right side is nothing but h of y, which is your initial entropy on the node, and you subtract the entropy after observing the feature xi. Okay. So now hy is constant over here for us, and this term h of y given xi will be changing based on feature x1, x2, x5. Okay. So whatever I is giving you the best result, you select that feature and you divide the GK. Okay. Then again you go for equation if all the samples are not belongs to the same class. Okay. So and then you keep on doing this class. Okay. So let me redraw just a sample. Like I have a y, we select for example out of x1 to x5, we select x2 as a feature. Okay, my data is divided over here based on x2 values, for example low or high. Now on this node, I may have a feature as x1 as a best feature, and on this node I may have x4 as a best feature. Okay, and then you keep on doing this job till the time samples does not belong to the one class. Okay, that's the ideal condition. Okay, Dr. Gagan, I hope your query is answered now. Okay, so for this example, let's take a look on information gain. Why we selected cylinder. So for starting from root node, when you have all the 40 records, so this is the cylinder with value 3, 4, 5, displacement with 3 values, horsepower with 3 values, and so on. Okay, and right side is the information gain. So it's a simple formula that you just place the values and you can calculate entropy values. So these are the information gain. If we given the 40 examples that we can call as h of y, and now x1 is my cylinder. If I observe cylinder as a feature, my information gain is 0.5. If I observe x2 feature as displacement, my gain is 0.22. If we observe horsepower as a third feature, gain is 0.38. Okay, so we have to maximize the gain, so we go ahead with cylinder. Okay, and then we split the data set accordingly. Now when to stop? So one is don't split if all the records belongs to the same class. Okay, that's the ideal condition. That like over here all 8 examples belongs to a bad class and none of the examples from the good class. That is acceptable. But at the same time, at some node like over here, that there is only one example and that example belongs to a good class. Now this another case when you cannot distinguish the samples, like your there are only 2 samples over here and the separation is 1:1. Okay, so we cannot break down this further. Or you can check again if you are not getting any information after this randomness. So there are 2 samples. You can check if what features are available now and whether they can help you to make it classify as 10 and 01. Okay. Now, so this is a basic idea for creation of decision tree. So, but when you have a large data set, so this is very small example, but when you have a large data set, when your number of features are like hundreds or in the range, then comparing each and every feature at each and every node is quite difficult, and even your data size is quite large, so that becomes a time consuming process. So uh, there was a paper which came up with extremely randomized tree, which introduces more randomness in the system. Okay, so what they suggested is, instead of evaluating all the features at each and every node, we can take root n of features, okay, as a candidate features, and then we'll select only those out of root n features. The idea is, like, if you have 100 features at the beginning, okay, so now you select only 10 features randomly, and then you find out the best among those 10. Okay, that's a one possibility. Like, one case you get the first 10 features as your selection, and you select only best out of those 10, ignore remaining 90. Another time you can have another 10, and then you select the best one. Okay, so just to reduce the time complexity or computational power. Okay, also the cut point, which is the threshold for values, if there are discrete parameter where values are quite large or keep on changing, like in the range of 0 to 100, you have different values, you can select one threshold for partitioning. Okay, so this is to reduce a computational cost. But decision tree is a weak classifier, because you can have probabilistically you can have a 50-50 chances to partition data in one class to another class. So then there is a concept called is ensemble learning, where you collect multiple weak classifier to make a strong learner. Okay, so that your decisions can be much better than a single classifier. So here is the case, like you have n learners are there, you have one input x, you give it sample x to each learner to make a decision or prediction for sample x, then the decision goes to a combination circuit, and then you get a final decision about x. Okay, so your learners can be homogeneous if they all are same. Okay, or your learners can be heterogeneous if they are different. Like, if my learner 1 is decision tree, learner 2 is SVM, learner 3 is a neural network, learner 4 is KNN, and so on. So if they are different, it can be a heterogeneous ensemble. If all my learners are same, like all are decision tree, it is called as random forest. Okay, and then there is a combination, that how we can associate uh, all the decisions and make a final prediction for the sample x. Okay, okay, so random forest is an ensemble approach where we have numerous decision trees for making a decision. Okay, so construction for each decision tree will be remain same, but they are random. Like what I suggested is, like implementation, you select root n nodes of features randomly. If you have 100 features, so you form one tree by selecting as a root n first n features, and then you keep on changing the features. Similarly, you can have another set of root n features, and your class decision tree will be different. Okay, so we have different decision trees and as an ensemble, and we collect together, and we use in general aggregation or combination as majority voting. Okay, so when a sample comes or test example comes, we pass on to each and every decision tree. Okay, and we just follow the path for finding a decision or making a prediction. Okay, so once you reach to the leaf node, you make a prediction. Okay, so for example, when a sample x comes over here, it will goes to each and every decision tree in the random forest. It will reach here, it will reach here in this tree, it will reach here in this tree, and based on the samples available on all these leaf nodes, there will be a prediction for sample X. Okay, now prediction will goes back to root node. Okay, and then we can make a majority voting. Like if it is just a classification, like there are three classes C1, C2, C3, then whichever class is identified by majority of decision tree, we will assign a class to the sample X. Okay, so that's the idea of random forest in depth. There have been some major changes in the random forest based on the design constructions. So one is extremely random forest, where the idea is to introduce more randomness by changing the features. Okay, so each tree should have a different subset of features so that they can learn different concepts from the large data sets. Okay, so idea is to introduce more randomness into the construction part so that you get to learn different concepts as an output. Second one is weighted random forest kind of constructions, where people who instead of working on majority working, you may work with some weights associated for making a decision, because everybody is not able to make a decision equally. Okay, so you can give weights to each and every decision tree, and then you make a prediction. So more like a weighted average mechanism. Then few studies has been done that how many trees are sufficient for making a decision. So is it 5, 10, 50, thousands, which is the good number? Such study is required. So one is such paper is there, and it may vary from problem to problem. There is no thumb rule as of now. Then based on reinforcement learning, can we construct a random forest that will be trained based on the examples which are misclassified from the previous tree. Okay, so like we are creating in this case one tree at a time, and the misclassification given by tree 1 will be given as a feedback to tree 2, and then misclassification by second tree will be given to the third one to train more efficiently. Okay, so reduce the misclassification. Otherwise, in general, we can create a decision tree in parallel. Okay. Then using rough set theory, yesterday what I discussed, rough set theory, there has been rough random forest, similarly fuzzy random forest, they are also there. Another method which came in 2016 is called XGBoost, which is ADPAR comparing with CNN methods, which is much faster for prediction purposes for large data sets. Okay, so this is the idea. Now let's come back to our problem of brain tumor segmentation. Okay, so this was a part of a challenge that I participated in 2017, and the paper came in 2018. Okay, so you can refer, available on internet. So so brain tumor segmentation has been attempted by obviously deep learning methods, one of the most popular, where majority of challenge teams participated with deep learning. Then including myself, few participated with random forest decision tree approaches, few were proposing SVM, mixture model, random field methods, then active controls were also there. Okay, so there are different varieties of methods available for solving one problem, and all were competing on the same dataset. So it was a nice part that everybody is using the same dataset only. So that result can be compared. And in the breast challenge itself, random forest has been used multiple times on by different researchers. Like one is solving by selecting equal number of samples for each classes, because initially I told in the beginning it's a imbalance problem. So you need so you have a different number of samples for different classes. So to make problem balance, the trivial solution is you take equal number of samples from each class. So few people have done this part, and then they build the random forest. Then Gaussian mixture model based work, followed by random forest in construction. Then work based on extremely randomized tree, then random forest, and then conditional random field has been used. Once you get the result from random forest, there has been some post-processing to remove the false positive negative. Then two-stage random forest has been proposed where you have layer of random forest, then cascaded architecture which is extending to 3-4 layers in different style. Then random forest builds based on the patients. Okay, so sample of patients taken and then build, random forest was constructed and so on. So these are the major overviews that how people have been attempting using random forest coding. Okay, so in 2017, the samples were 285. Out of that, 210 was high grade glioma and 75 was low grade. And for each patient, there was a 4 modalities given: flare, T1 contrast cadence, T2, and a ground truth. And each were of dimension 240 by 240 by 155. Okay, so it's a 3D volume where an image, if you extract, is of size 240 by 240, and there are 155 slices for each modality. Okay, so there are 5 volumes available for each patient. Okay, so it's a quite large data set even at that time, and then it was keep on enhancing. And the classification is the label 1 is to be given for necrotic region or non-enhancing region, which is a dead tumor, which is like a green color, which I showed in the beginning part. Second is edema, which is a swelling area shown in the yellow color. Level 4 is a blue color, which is enhancing tumor, which is like growing and may progress in future. And the last one is level 0, which consider a background and the healthy tissues. Okay, so we don't have to worry about the healthy tissues. We just have to consider level 0. Okay, and the sub-regions which are to be identified is defined as if enhancing tumor as level 4 only, tumor core which I have shown in the color red, which is combination of level 1 and 4, and the whole tumor which is combination of level 1 to 4. Okay, so this was the classification of sub-regions that we have to classify. Within one area you have to classify all. So if you just find out whole tumor, then from whole tumor you have to find out tumor core, from tumor core you have to find out enhancing tumor. Okay, and the complete data which was provided is co-register, so image registration is done properly, and resolution was same, and brain skull has been removed from all the samples or all the patient data. So it was like a nicely pre-processed data set given for the challenge. Okay, so you don't have to worry about the pre-processing part over there. So what we suggested over there is kind of a 2-stage prediction based on the philosophy that when we visit a doctor, uh, doctor also learns from the patients. Okay, so like they have a different patients and they learn from the patient behavior, how patient is behaving or how their treatment is working. And when a new patient comes, so based on their experience, they try to correlate like what kind of treatment they have done in the past. Okay, so what we did is we created a random forest for each and every patient individually because we have a large size data set available. Okay, and that has been sufficient for us to create a decision tree for them. So we have created patient data for each and every patient, random forest for each and every patient, and then once we get the data or decision, we have another aggregation over here, which is shown as a red color over here is aggregation, and then we make a final prediction over there. Okay, now remember over here we are giving input as an image, and for image we have to label each and every location, okay, or each and every position in the image. So our input is a 3D volume, and final prediction also has to be 3D volume. Okay, so we have to predict labels for each and every location. Now we have generated handcrafted features for this problem. So we have created two AKI features like we started with 30 features, then 90, 90 to 150, 180, 200, and we reached to 280 as a part of challenge in the last. So like 5 features were intensity features, which is coming from each and every model key. Then texture feature based on the gradient, mean, max, mode intensities after removing a small area of noise based on different window size. So that consists of 150 features. Then statistical features like how data is distributed in a small window. Okay, so over there we have used max, mean, common statistical measures, then skewness, cycle moments, and so on 2 different scales. So that consists of 180 features. So that makes a total 280 features for one patient. Okay, and we are learning region of interest where the tumor is present. We learn that region of interest, we identify, and for each pixel over there, we or each position over there in ROI, we generate this 280 feature vector. Okay, so if I have 100 locations in the patient where we identify this is a tumor location, so for 100 such pixel locations, we create a 280 feature vector. Okay, so my matrix is now going to be like 100 cross 280. Okay, and we have a random forest we construct with the 25 trees over there. Okay, so for each patient we have a 25 trees which is heuristically estimated for decision making. Sorry. So what we do is for training purpose we remove a bias field correction, which is pre-processing required, then finding out the region of interest, which is tumor area. Then we generate feature vectors for each pixels or tissues in the ROI, and then we create a random forest for each ROI. Now, when a test sample comes, so what we do is we do a pre-processing, we find out the region of interest in the test sample. Now, there are two paths which have been shown here. That one is the bottom one is once we get a region of interest, we find out features for each and every location in the same way what we discussed. Okay. Now, the upper path is once you find out the region of interest, because there are 280 random 85 random forests because we build for each and every patient, so we cannot get decision from 285. So what we did is from region of interest we compare the region of interest which are similar. Okay, so we have used mutual information criteria to compare one region of interest from the all the patients data available as a training. Okay, and then from that based on mutual information we select only best K matches. Okay, so over here in experiment we have used 11 best matches. Okay, and then only those 11 will participate in the voting because we are identifying the similar matches, and then those only 11 should participate. Okay, and then we take random forest for those 11 cases, and then the samples which are generated from this path goes to random forest over there. Okay, and once we get the decision from those 11, accordingly we take a decision over there as an output. Okay, so this was a cases that we had a whole tumor which is mean value for all the training data is 0.62, tumor core is 0.49, enhanced tumor 0.47. This is on another measure which is called Hausdorff. So these box plots are representing the results. And there are cases like how it should look like. There is a ground truth available for training data set, and this on the right hand side how our approach is working. Okay, so for whole tumor, the Guy's coefficient is 0.9239. Okay, so where we are able to capture most of the areas which are tumors. Then for training data, this is 4 model keys available as an input image. This one is ground truth, and you can see in this area, in this result, we are not able to capture the tumor area at large. Okay, and that's why the values are also quite less over here. Over here, in this case, like we have uh, able to capture most of the thing. That's why our whole tumor is around 0.92, but other measures you can see we are completely ignoring some of the areas. This is another result where we are not able to identify enhancing tumor at all. Okay, so it's a completely zero value. And another result where it's more like we are able to capture some of most of the areas. Okay, this is on the validation data where we don't have a ground truth. Okay, so we just predicting the labels for each and every area, and the result is generated from the organizers portal where we just upload our segmentation result and we get the outputs over there. Over here we don't have much tumor area, it's very small, which is over here tumor area, but we are only able to identify this much portion. And this is how we perform on the validation data, where most of the cases we able to go with 0.8 and above in case of whole tumor. Okay, so other details for results you can find out in the paper. Okay, any queries so far over here before I move for another topic?
Please raise your hands if you have any queries.
Okay, if no queries, then I can go ahead. Okay, so this portion is based on random forest again, but philosophy is in the line of deep CNN. So authors Professor Zhou and Fang proposed a deep forest, which is uh, inspired from the deep neural network. And can the random forest be considered as a replacement of deep neural network? So deep random forest is proposed in 2018 at the same time when I was working on this tumor segmentation problem with a two-stage mechanism. So the idea of this method is to have a layer kind of representation, what deep learning methods has. Okay, and but with the less number of parameters. Deep learning is differentiable module, non-linear, but random forest is easy. Okay, and it can be very simple in terms of implementation because we can implement multiple trees simultaneously. Okay, so can we compete with the CNN? So that was the idea, and they proposed deep forest. I'll just quickly go through the notion like how it has been done. So this is how structures they propose, like layer by layer structure. So you have an input feature vector, and then you create a 4 forest. The black color are a conventional random forest, and the blue color are the extremely randomized forest, which where you have more randomness in the construction part. And for output, you get, for example, if there are 3 classes, you get output for all the 3 classes, and then you concatenate the input feature vector as an output for this level 1. Okay. So level 1, you will get output from all the forest, okay, and then you concatenate the input feature vector, and that goes to an output in input to the level 2. Okay, again output of level 2 is concatenated with input feature, and that goes to the level 3 and so on. Okay, so this keep on doing the layer by layer representation where you have an output from the previous layer in the input and input feature vector. Okay, and then in the last, like a fully connected layer, you just take output of the last layer, level n. Okay, and then you just take average of all the classes. So this is representation for class 1. So you take output of all the 4 forests, take an average or max value, and you make a final prediction. Okay, so that's the idea of deep forest. So you keep on adding the layer by layer representation over there. Okay, and instead of nodes over here, decision trees will be acting as a node in the neural network in place of neural network. Okay, so in case if your features are like a one-dimensional representation, so they have been divided into different parts. But if your features are in image format, so the authors propose to find like a window-based approach where you just have a patch of an image and you convert that patch into 1D representation, and then you keep on giving that patch into 1D vector to the architecture and it will do the processing. Okay, so they call the one part which is called multi-grain scanning, okay, where they identify the features by performing chunk by chunk representation of input data. Okay, and they generate 3 type of feature vectors. One is like 1806 dimensional feature vector, then 1206 dimensional, and 606 dimensional. Okay, and then they proposed 3 level for each representation. So like this first 1806 goes to the level 1 forest, that output is concatenated with input vector, goes to second, then goes to third. Okay, when you goes to second level, you take input of this 1206 dimensional feature vector, and then you start processing. Sorry, okay, I made a mistake. Just let me follow again. So you start with 1806 dimensional feature vector and giving an input to the 4 forest. You take the output and you concatenate the 1806 dimensional feature vector as an input to the second level. Okay, then in the second level you generate an output and then you concatenate with the 1206 dimensional feature vector, giving input to the next level, and then you get the, or you concatenate with 606 dimensional feature vector. Okay, and then you repeat the cycle of these 3 layers multiple times. Okay, and then in the last, when you do actually averaging or pulling, you just take a weighted average and you make a final prediction. Okay, so this is how authors have proposed deep forest architecture, and then they have compared the for various applications like MNIST dataset is images, uh, and then they compared different deep learning architectures and other classifiers with the proposed architecture. They called it as a GC forest. Okay, so then override database or the facial images, then GT Gen, which is on the music dataset. So they have generated MFCC features and then they've done the classification. Then EMG datasets, then IMDb movie rating dataset. So they have compared with other methods. So more or less they found better performance or close by performance, and this can be another replacement of using CNN. Okay, so they have compared like a Cipher 10, which is well-known data set of images, which is a collection of 50,000 images into 10 classes. Okay, so they have compared with ResNet, LXNet, then GC Forest, their proposal, Deep Belief Net, Random Forest, Simple, Logistic Regression, and so on. So more or less they found comparable or architecture can be tuned accordingly. So we have used another in last year competition for breads, we have used deep learning architecture in the similar line. Okay, and we created over here is a 416 features instead of 280. Now we extend it to 416 features which are handcrafted on the similar line, where we have proposed LBP feature. So another feature method is called linear binary pattern in the images. So LBP is well-known feature and the simplest to calculate. Okay, so in images, so we use, since we have a 3D data, we use three representation. So like XY plane LBP feature, YZ plane LBP feature, XZ plane LBP feature. Okay, and we have a representation like this one. So if this is an image patch where values representing your pixel value, so with respect to the center pixel, the LBP feature is computed like how difference is. If it is less than the center value, it will be replaced with 0. Okay, so if you look at this one, uh, 1 is less than 7, so it is replaced with 0. 8 is greater than 7, it is 1. 7 is greater than 7 or equal 7, it is 1. And for 9, so this is one LBP representation. You convert this like this binary feature, and if you want to see this as a decimal representation. So this is the way that we propose to have LBP features in a clockwise direction and anti-clockwise direction. Okay, and that makes 192 features for each and every region of interest or pixel value in the region of interest. And then once we have values, then we propose forest, deep forest again in the same way what has been proposed as the original author of GC forest. So we have 4 functions and we give it as input to different forests, and in the layer by layer we are configuring them over here, and then we make a final prediction. So we have 4 layers. So we restricted the computation to 4 layers as an implementation. Each layer consists of 4 random forests, and we also try to make a data a balanced data. Okay, so we have randomly taken equal number of samples for each classes and from each patient to make a better or a balanced data set. Okay, and we trained over 100 decision tree with maximum gap size of 50. And these are the performance of our approach on 2 patients, okay, on different view representations. So all these which are, you can see small dots or small areas which can be removed by post processing. I think so this can be easily removed by post processing. And this is a evolution of data sets on different cold tumor, enhanced tumor, and tumor core. Box representation, how our values are ranging over there. Okay. Okay, so this is all about for our another task that we participated in last year for breast challenge. Okay, anyone, any query over here so far?
Please raise your hand if you have any query, or you can write your query in the chat box.
Okay, so if no queries, let me go ahead. There are few other applications where random forest has been used for, so maybe I just included if somebody is interested or may helpful for other works. So one is like image classification, a typical problem of image processing. You just classify images. So people have used random forest over there. There are few well-known data sets. One is like Caltech 10001. where 101 object categories are there, and number of samples varies from 31 to 800 in each category. So this is also you can consider as an imbalanced dataset, where some object have 31 images, another object have 800 images, and images are of 300 by 300 pixels and this has very large class variability because number of samples are quite varied. Similarly, there is another dataset called extended dataset is Caltech 256, where it is increased from 101 to 256 object categories. Okay, and number of samples also is lowest is 80 in some of the classes and maximum is 827. Okay, again it has variability in the dataset. Then MNIST dataset where you have 60,000 credit samples and 10,000 examples or test data for handwritten digits, and image size is 20 by 20. So what the authors in they have done is they have proposed visual of bag of visual words inspired from NLP's bag of word features. Okay, so bag of word feature is well known in information retrieval. So they have defined bag of visual words representing the images. Okay, so they have a key point and descriptors they have taken for image patches. So like if this is an example image in the first row, so they have taken the patches of the image, okay, in the second row, and then they constructed uh, histogram of visual words, okay, and then from there they define a dictionary of visual words. And then once we have a features available, we can perform or we can implement random forest with these are the parameters that we have worked with. So this is one of our work called exponentially weighted random forest and compared with the conventional random forest for image classification. Okay, so I'm not discussing uh, about EWRF. But this is just to show the random forest to be used as different application than medical. So this is for image classification. So this is how we set up an experiment that we have like 40 cleaning examples for Caltech 101 and 40 tests also, and the number of classes which are original classes are there. Then pre-gap where we have extended our experiment, and then the next column is the accuracy from RF, conventional RF, and what we achieve from our exponentially weighted random forest. Okay, so you can see in most of the cases we are getting a better accuracy than the conventional approach. This task is to for image annotation. So how we tag images
Dr.
using random
Ashish.
forest.
Yeah.
Yeah, sorry.
Hello. Yeah, Dr. Ashish,
Yeah.
this is Professor Nidhi. I have a
Okay.
question actually. Can you go back to the 82nd slide?
82nd.
Just
Yeah,
before
this
this
one.
table. There was something, yeah, this features, why there is under square root of V, the next one.
Okay, this is for making a randomization because when you have a large number of features, you cannot evaluate each and every feature for computation in decision tree. Otherwise, it will be
Yes.
very time consuming. And when you go for random forest, because if you take each and every feature at every point, then your trees will be safe, and your random forest will have all the trees which are similar or near to similar. So that is how we introduce randomness in the construction. So you take subset of features randomly and you learn different concepts. So idea is each
Okay.
tree in the random forest should be disjoint in terms of representation, or they learn different concepts from the data sets.
Right. And the next iterations is 10. Iterations are 10. So
Yes.
can we have some other stopping criteria or in the given experimental setup, you have taken 10 iterations, whatever value comes in?
Yeah, based on the results that there is no improvement coming up or significant improvement, so we just stop like that. So all these are experimental parameters. There is no thumb rule as such.
Yeah, we can
This
take
one
any
you
other
have to use.
stuff. Yeah,
Yeah.
thank you.
Yeah. Okay. Any other queries? Anyone? Okay. So another example is for image annotation, where we tag an image from learning from the random forest. Okay, so these are the original authors which I have cited, and they have a paper long back. So now what they have learned is a random forest for finding out for a classification. Okay, so like we can have a classification of one object into multiple categories. So like a newspaper column can be considered as a political, election oriented, democracy oriented. Image may contain multiple objects like tiger, grass, river, sky, and so on. Okay, so if we want to classify one image, or we want to tag the objects in the image, okay, so that's the problem of image annotation. Okay, so that is called multi-label classification, where you have multiple labels available for a given image. Okay, so the authors proposed like a random forest, and they called a new concept called semantic similarity measure, SSM, and semantic nearest neighbor, SNN. Okay, so what the authors propose is idea is like this. Let me skip this part, theoretical part. Here is the thing. So what we do is you have a query image, and from query image you give it to the decision trees in the random forest. Okay, your forest is learning different concepts via decision tree. Now this query image based on the features will fall to different leaf nodes in the bottom. Okay, so like there are 4 different leaf nodes are over here. Okay, and on these leaf nodes there are few samples already existing based on our training. Okay, so this is highlighted, our query example is highlighted in color red box, and the samples which are available on the leaf node is highlighted in different colors, so blue, green, and so on. Okay, now if we are learning a concept, and if we have a similar concept of query image, it should have a similar samples on the leaf node ideally. So what they have compared is a semantic neighbor. For this image, what are the semantic neighbor images? So you can see this red color box is there on all the 4 leaf nodes, and then few common like blue color is appearing 3 times on the 3 leaf node, green color is appearing 2 times, yellow is once, magenta is once. Okay, so this is how they computed SSM, semantic similarity measure. So this is with the query image. With this one, these this image is appearing 4 times, then blue color is 3 times, this one is 2 times. So which is very close, they are using this notion. Okay, so they use this information for further processing, for further tagging. So whatever tags which are available to the neighbors, you can directly assign those tags to the query image. Okay, so that was the idea of image annotation class that has been done using random forest. Okay, so there are different approaches available. This is only one example just to highlight how this problem can also be taken here or can be tackled using random forest. And these are the few results that we have just taken from the paper just to showcase how they can compare. So like this is the labels are, the left side is query image, then from random forest, and then proposed approach by the authors, and they have shown which are the labels they are getting correct, which are labels they are not getting correct based on their measures they have used or proposed. Okay, so this is another area of research. Okay, so this completes my talk. Just few resources if you are really interested to look other than the CNN methods. So this is one book which is called Decision Forest for Computer Vision and Medical Image Analysis, written by well-known authors in the random forest. So I do follow personally Crimici Antonio. He's in Microsoft UK. He's one of the pioneer working in the area of random forest. Obviously working on deep learning also, but he had lots of paper on random forest. And then few other papers where people are working. One is deep neural decision forest, where current trend is to combine neural network with random forest. So then this was the starting point, and then followed by there are few papers where people take features that I talked at the beginning, that handcrafted features are more difficult to find out. So, and neural network is doing for us automatically. So what some people have done is they have generated features from neural network and then implemented random forest using those features. Okay, this is similarly in the line of presently new, which is like explainable AI. So we have a rule-based possibilities from decision tree. We can derive a rules and we can classify with the justification why such outcome is there. But neural network, it is very difficult to find out such rules. Okay, so explainable AI is another upcoming area or people are working already where we need a justification for an outcome. Okay, so and another one is a multi-output random forest or basic things like if you want to learn. So one is MS thesis from Gillies Loop, which is available on archive for understanding random forest, very basic things. And then there are another set of work get by people is on unsupervised random forest, where you, although random forest by genesis is a supervised approach, but what will happen if ground truth is not available? So can we use unsupervised version? So this book, which is on the top, also have couple of chapters working on unsupervised random forest. Okay, so this is all about random forest. Majority which I try to cover to give an exposure. So thank you everyone for listening, and if there are queries we can discuss. But this talk or this work is done with multiple people. In fact, I was associated with Professor Pradipta Maji as a visiting researcher to his lab. Then one of my PhD scholar also worked in some of the parts of this presentation, and the Samir Sheikh is MCAT pass out from Superlike Vadodara, who also worked on the brain tumor segmentation that we submitted last year or last 1 year back. So this is all about this talk. So I'm now open for questions. If you can type in the chat box one by one.
Yes, sir. So I request all the participants, if you have any queries, please type your questions in the chat box. You can also raise your hands, we'll unmute you.
Dr. Ashish, can you compare, I mean, please suggest what is better, deep learning algorithms or maybe, doing these classifiers, because nowadays lot of work is
My
being done on,
colleague who is sitting next to my office is working on
sir,
deep learning,
sir.
and I'm not working on deep learning most of the time.
Actually,
So
deep learning has lot of issues, what I have felt.
that was the starting point that I started on random forest with my PhD scholar Vikas Jain. So because you need resources, 5 years down the
Yes.
line, you need resources, power, and all those things, and that was not available at the beginning. But random forest is easy to implement. You can do parallelization. You can generate multiple trees simultaneously, and few advantages are already there. That's why people are still working on random forest, including myself. And conventional methods should be revived again with comparison to other methods. And explainable
Just to
AI methods are actually based on random forest where you can get justification or understanding how or why it is working.
And how can we, this new term that you have, just used, explainable AI. Earlier,
Yeah.
this term was not there. So how
Yes.
do we differentiate between this AI and explainable AI? This is a very recent term coined in.
Yeah. So explainable AI is the idea is because deep learning you have millions of parameters and which parameter is playing what kind of role in your answer nobody knows. People have attempted to identify or exploring the CNN like how mathematically it can be derived, but still there is no conclusive things. People are working, like my colleague is working on such areas also, but what explanation that I have given in the beginning, that I can derive a simple Boolean logic rule from a decision tree. Even if I have a random forest, I can derive rules for any classification why my classifier is behaving like this. Okay, so I have a justification, like we are teachers. So when we do assessments, the student may ask why you have given me this much marks. So we need or we have a justification. Same way these methods will have a justification. Can they explain the outcome? So that's
So,
the idea of explanation AI.
so does that mean that deep learning will never fall into the category of
No,
explainable AI?
no, it's not like that. People are improvising deep neural network methods also.
Yes.
So people are they are reducing the
Um,
layers. They are looking for another operators which can give a better representation.
yeah, there are a lot of ablation study they have to do in their
Yeah.
architectures.
Yeah. So
So that
ablation
is
study
helping them.
came. Yeah, ablation study came 2-3 years back only. And
Yes.
I'm part of reviewer of like Mikai from last year, and most of the papers do come with the ablation study. Otherwise, it won't be possible to understand why neural network is working.
But again, one point over here, just to discuss,
Yeah,
when we are talking of ablation study, and it is again, don't you feel that it is just a guesswork? This must be happening within the, architecture. That is why the architecture is overfitting or underfitting. So
yeah.
again, a
Somehow
guesswork.
most of the works are guesswork. Although there are mathematical backgrounds and everything
Yes.
is justifiable, like random forest. It's also a kind of a guesswork. There is a proper philosophy of defining a decision tree. Like if you have a 10 features, 100 samples, you can use all the features at every node, you will get a decision tree, the best or optimal decision tree. But in case the problem is like 10,000 samples and 1,000 features, it won't be possible. Like it will be very time consuming. So you go for randomness. So for randomness, there is not much control over there. You can justify with few assumptions. You can do some mathematical rigor, but it won't be under control. So that's a possibility over here. But there should be a intuitive idea that how things are working in any classifier. So like neural network is called black box because of that only. Most of the time we don't know why should we have a layer or we should not have a layer.
I mean, at the end of the day, it is just hit and trial, removing one layer, removing, changing
Yeah,
the
most of us are
activation
doing that
function.
only.
Yeah, got
So,
that.
so it's
Uh,
not like we should go always to CNN or we should move to RF, random forest or any other method. Better to explore each and everything.
yeah, with analysis only we are going to learn. I'll
Yeah.
just take up one question from the chat box. This is
Okay.
from Aditya Kameshwar Rao.
Okay.
Apart from
Yeah.
DL, is there any possibility with RL will work for own data sets?
Uh, Aditya, can you just explain the full form of RL? Is it
Uh,
reinforcement learning?
Archita and Sakshi, can you please unmute Mr. Aditya?
Yes, ma'am, I have unmuted him.
Thank you.
Yeah, so reinforcement learning is already there. People are working also equally. Only thing is, it's more time complex and computationally complex reinforcement learning. But still, people are working. And if you are asking for own data set, what kind of data set do you have? And what is the problem that you want to solve? So you have to match your problem and your data set, and then you have to design a philosophy, like what you want to achieve. So there should be a synchronization. It's not like a blind game that you are playing with reinforcement learning. You give any random data, it will do something eventually, but it won't justify. So you have to
Sir, I
be
would
careful while matching method, data set, and problem.
Sir, I would like to add over here, Dr. Ashish.
Yeah, please. Yeah.
Like the way he is asking will work for own data sets. What my experience is, of late we have been working with on a project with AIMS Delhi, and we have that medical data. But there is a problem when we go for publication. The problem is the moment we communicate a paper, the comment comes in, please compare the results for the standard data set. Although we are getting good results for on AIMS data. If I
Okay.
just take the terms, take the context of Dr. Aditya or Mr. Aditya, it is a data set which is not there in the literature. We have newly created it, but due to the ethics policy, we cannot, make it public.
Yeah,
But
that
the
will be
journal
always a problem.
publication,
No, no,
yes,
that
they
will
are
always
not
be a problem
accepting the work.
because you need a common benchmark.
Yes. So
So what I
with
would
that
suggest is
comment,
first
uh,
you compare your approach on standard data sets, and
yes.
then you publish the result on the other data set, which is your own kind of. So that will give a confidence. Okay, it's working on standard data sets and it's comparable. And then you can do additional work that you have own data set and method is working.
Yeah,
And I would
that,
suggest
yeah.
on your own data set, uh, uh, with performing your own approach, you also apply standard algorithms on the similar line so that people will also get to know, okay, what other methods are working on your data set, how your approach is working, additionally, how other approaches are working.
And at the same time, when they are using their own data set, and along with that, they, run their architecture for a standard data set, I think that will add weight to their paper because it will be a cross data set analysis. And secondly, what Mr. Aditya you can do is you can publish a paper with your data set. Nowadays, many journals they are accepting
Yeah, that
papers
is
on
more
data
standard
set.
work. Yeah.
Yes, and then with time it may become a standard.
Okay, ma'am. Okay, thank you.
Sir, we have a question in the chat box. What is
Yeah.
key difference between decision tree and random forest?
Uh, Decision tree is a smallest unit, or you can say atomic unit, which is a kind of a weak learner in terms of machine learning. But random forest is ensemble or collection of multiple decision trees so that we can improvise uh, or we can have a strong learner which can learn different concepts. And there is more randomness in the random forest so that we can learn different concepts, which is not there in the decision tree much. So decision tree used to be considered as like tossing a coin. You toss a coin, you get either head or tail. So if your data set is more like having only binary values in the features, like low or high, or medium or high, something like that. So there are equal chances that either you will go into low or you will go with high. So it's a 50-50 chances most of the time. So that's why it was considered as a weak learner. But accuracy wise, yeah, random forest is performing better.
Hello, sir. Sir, I'm
Yes.
Sakshi from BTech fourth year. Sir, I just want
Okay.
to ask a very small doubt. Sir, is random forest good for small data set?
Ideally, no, but what is
Okay.
small, nobody knows.
Right,
It's a
right.
term. So how much small you are talking about may be different.
Okay. Sir, but random forest algorithm may change by a small change in data. Then why are we preferring random forest algorithm?
No, random forest, if you have a large data set, definitely it will perform better. But that what is I'm saying is, if you have a very small, like 100 samples and 10 features, and if you create
Okay.
a 5 decision tree, it won't help you much. Even 10 or 15 will be overfitting. And if you make only 2 decision trees in random forest, it's a meaningless.
Yes,
So
sir.
idea is, if you have a concept to learn, different concepts from the problem to learn, then random forest will be helpful than the decision tree. Like decision tree, you will learn one concept. Uh, if I have to classify image like a
Okay.
tumor or non-tumorous, that's a binary classification. I can learn from decision tree. But what
Right.
problem I discussed is having multiple reasons are there, one within another, that you cannot learn with simple decision tree. So you need some powerful method. So random forest will work better on such thing. Like image annotation is another example. Then you can have more randomness and you can learn different things parallelly. So one tree will give you one information, another tree will be giving you another information. That's the idea.
Okay, sir, got it. Sir, we have one more question from Dr. Sachin Kumar, sir. Sir, he is asking that can a random forest be used as a hyperparameter?
Can you unmute him so better we can have a
Sure,
better discussion?
sure, sir, sure. Sachin, sir, can you ask your query again? I think maybe there is some problem with this audio. Sachin, sir, we
Okay.
can't hear you.
Okay, Dr. Sachin, like me, what I understood is, but one thing is hyperparameter is a parameter associated with an method. Okay, so like neural network, there are weights associated in the network architecture that we are learning by giving the training. Okay, random forest is another approach where it has its own parameters. So those parameters that we require to learn, we call that as a hyperparameter. So random forest itself has a hyperparameter, kind of like how many trees you require, what will be the samples on the leaf node, what is the gap of each tree that you are looking for. So all these are parameters associated with random forest itself. Okay. But if you have another notion of hyperparameter, you can type here.
So we have one more question from Dr. Sachin. He's asking that how are random forest and GBDT the same?
So GBGT is a different concept, or you can say a variation from decision tree. So it's a gradient boosted decision tree where you, instead of looking for each and every sample, you look for a change of values or gradient in the sample values. Okay, so it's a variant of decision tree. Random forest is having a different philosophy. It's a more like an ensemble approach. GBGT is more like a decision tree, you can say. I don't know if there are papers which are like GBRF, gradient boosted random forest. There may be possibility they exist, But idea is different, where you just use in GBGT gradient or change in the sample values. How different two sample values are, that is the philosophy in the construction.
Okay, sir. Do we have any other question from our participants?
Yes, we have another question. We have another question in the chat box. Is there any openly available data for our own algorithm trails?
Can you unmute Mr. Aditya?
Sure.
Can you hear me, sir?
Yeah, please.
Yes, sir. Actually, my question was to test either DL or reinforcement or deep random forest architectures to test. Is there any available data sets are there? In one of your slide, you said some brights and some other data sets are there available. But is it openly available, or we need to have we need to have any rights for that?
No, what data sets I have mentioned or sources, they are openly available. You can just log in or register on their portals and you will get access to data set. Only thing is you have to mention from where you have collected the data. So every data set has some conditions, like you have to cite the proper paper over there. That's the condition that you have to take care, and they are openly available data sets. There is no copyright or payments that you have to make.
Okay, sir, because in one of your slide you said that it is a the data set was used for some challenge, some competition kind of thing.
Yeah, competition, but it's a academic or open challenge, so anybody can participate. There is no charges to be paid. Only charges if you are going with publication further.
Okay. So for the initial trials, we can use the data sets, right?
Yeah, sure. Free of cost.
Okay. Okay, sir. Thank you.
Okay, so if anybody has any other question, please raise your hand.
I think that's all, Sakshi. We can conclude.
Okay,
Okay.
I have a question to Dr.
Yeah,
Nidhi.
Dr. Ashish. Yes, sir. Please.
If you allow me, can I use this platform to for publicity of our event?
Yeah, sure,
Because
sir.
I'm associated with IEEE also as a
Sir.
IEEE Gujarat section, and
Okay.
since you raised the curiosity for explainable AI,
Sir.
we are coming up with an event called Explainable AI as a part of our event of emerging research trend in engineering.
Sir.
So we have a 3-day event in October 1 to 3 on explainable AI. We have 6 or 7 speakers, and we are planning in the evening sessions only so that everybody can join. So if those who are interested, I can share the brochure with the organizers over here, and then it can be passed on to other people. If you are looking forward more on explainable AI, how it can be done or what is that all.
Yes, sir. Sure. You can share the brochure with us and we'll post it on their WhatsApp group and the Google group,
Yeah,
sir.
sure.
We'll do it.
Okay, yeah, thank you.
Thank you, sir. It has been a nice session and very informative. I'm glad that many of the participants took interest and, asked their questions. Already they are writing. Please share, sir. They'll be
Yeah, I'll
coming up,
share.
sir.
Yeah, I'll share.
Yes, sir.
Already registration we started, so yeah, I'll share.
Right, sir. Sakshi, you can wind up.
Sure, ma'am, sure. On behalf of IGDTUW, I, Sakshi Patel, would like to take this opportunity to express my heartfelt thanks to Dr. Ashish sir for such an amazing session. Dear sir, we are very grateful for the time and effort you took to share your thoughts and experiences with us. Today, we learned so many new things from you and we look forward to learning more. We hope you can join us again. Thank you for the highly inspiring time with us. Last but not the least, thanks to the whole audience for your unwavering attention throughout this session. We look forward to having you again in our next session. Thank you so much, sir, for such an insightful session. Thank you so much,
Yeah.
everyone. Thanks a
Thank you
lot.
so much. Yeah. Thank you.
Thank you, Dr. Ashish. We'll look forward for further collaborations and, expert lectures from you, sir.
Yeah, definitely. Yeah, sure. We
Right.
can discuss.
Yeah. Thank you, sir.